Hi, good morning, everyone. Thank you for joining. My name is Sunil, and I have a PhD in machine learning. I've got 15 years experience in the industry, and I've come here for great learning industry session to have a mutual interaction between us. I'm definitely looking forward to learning quite a bit in the next 3 hours, and I hope the same is going to be with you guys. I hope you're all able to see my screen now. So if you're able to see my screen, just ping yes on your chat box. Yeah, I'm just waiting to see yes. Okay, Tushar Gupta says, no, he's not able to see the screen. Just give me a second. I'm going to see if I can broadcast it once again. Hey, Birendra, good morning. Thank you for joining the session this morning. We're going to start in a couple of minutes. We have some technical difficulty. Piyush from Great Learning is trying to help me. Yep, I reshared the screen. So just let me know if you can see my screen. Ping a yes. Very good. Thank you, Avinash and Birendra, for confirming that you can see my screen. Right, my name is Sunil. I have a PhD in machine learning from one of the reputed South Indian universities. I've been in the industry for about 15 years. I currently work for a US financial giant in Bangalore in their artificial intelligence center of excellence department. Um, I've recently published a book on machine learning. It's available online for you to buy. If you go to Amazon.in and look for our machine learning projects, you'll see my book here. If you're willing to learn more about machine learning projects in R, please go ahead and buy the book as well. Thank you for the opportunity to market my book as well. Piyush is here with me. Piyush is from Great Learning. He's going to help me with all the technical difficulties I may have during the session. Um, let's give it a couple of minutes before we start. Um, so I've heard from Great Learning people that you've all had some background in terms of the course. You have all attended some courses on machine learning already. So today's session is more going to be a recap of whatever you have learned over a period of time, as well as uh, how do you integrate all of the learnings that you have done over the last 3 to 6 months. Say, for example, you've independently learned about how to collect the data, how to clean the data, how to manipulate the data and make it ready for modeling, how to build the models, how to do feature selection, how to make visualization. You have learned all of these topics independently, but today's session is going to be more about how do I integrate all of these learnings and how do I go about building a high performing model. And unfortunately, most of the courses they touch upon concepts of building the models. However, there is a lot more work post building the model as well. So we're going to be talking about what is that you get to do once you build the model. So typically what happens is you basically divide your test data and training data, and you apply whether it is tenfold cross validation or separate test data set. You basically evaluate your model and see how far it is performing. In real world industry situation, the work from a data scientist wouldn't stop there. There is a lot more work to be done. So I'm going to be touching upon what that work is and how do you go about learning those skills as well. So one of the biggest things is when you attend an interview for data scientists, if the interviewer wanted a guy with real industry experience and not just somebody who has learned courses from Coursera or Udemy, then typically what we do is we ask questions about productionalizing a machine learning model. And that's the gotcha moment. If you're not able to answer those kind of questions, we already know that you're not somebody who has worked on real world machine learning problems. Rather, you just have a theoretical understanding of how to build a machine learning model. So pay attention to it, and over the period of next 3 hours, we're also going to talk about several tips and tricks we use in the industry in order to build models. Rather than having to do all the hard work, there are lots of libraries that will help you to build models very, very easily. Um, we will be talking about all of them. But before I go into all of those concepts, I really want to ask you a small question. What do you think is the output of a data science project? Just ping me online. I'll give it 30 seconds time for you to ping in your chat box. What is the um, what is the output of a project, a data science project? Okay, Sudhakar Reddy says it should work in production. Okay, prediction. Ankit Kapoor says it's production. And Nagapavan Kalepu says a model is the output. Gaurav Srivastav says depends upon what the problem is. Very good, Gaurav. Can you expand your answer, please? What do you mean by depends upon what the problem is? Okay, Avinash says improved business outcome. Okay, predictions of Nehar says predictions of future results. Okay, sure. All of these are good answers. Kunwar Singh says help business to make decisions. Yes, that's right. But more from a technical perspective. Actionable insights, Akshay Singh, very nice. Okay. All right, help business to make better decisions. Okay, right. Let me clarify my question once again. So there are two kinds of data science projects that you would do. Typically, one could be an analysis project. Say you would have learned about clustering in your coursework. Typically, when you do clustering or segmentation kind of exercise, there is no model. All that you did was an analysis. The output of such an exercise is going to be just identifying the patterns, like Deepa Shetty is informed on the chat box. Yes, you will identify the patterns, and then you create visualizations and present it to your management to say that this is what I have found in my data set that you have given me. This is the algorithm that I've applied. You're going to tell them a story saying that, okay, this is how I arrived at this conclusion, and this is how you can use this insights that I found from your from the data. Uh, in this particular case, there is nothing called a model, right? So all of you in agreement with me then, right? So, but in another case where you are building a project or a data science project for predictions in future, obviously you have a predictive model there, which you need to take it forward for deployment. And it's not just about creating the visualizations. It's not about creating a high performing model. There is so much more there. We will be talking about all of those aspects that you will be doing post creating a model as such. Yeah, thank you for the answers. All right, so this session is going to be a walkthrough of the PPT that I have created. It has some 84 slides plus an additional deck, which is specifically talking about how do you explain a model that you have created. Um, it's all about interpretable machine learning, So that is something which I have considered as an optional topic for today. If time permits, we will cover that. Otherwise, we're going to exclude that as such. Rest of the topics we will be definitely covering. Um, and I have some notebooks as well that are coded in Python. I mean, Anaconda Python 3.2. We're going to have a look through all of them along with the results, and we're going to understand why certain things need to be done certain way. Unfortunately, it's extremely difficult to carry out an interactive session on an online presentation like this. Therefore, we will allocate about half an hour time at the end of the session, so you can type in your questions, and I'll be able to answer those questions separately. So, have a book and pen by your side, and try to make a note of all the questions that you have, and we will come back to all of these questions at the end of the session if that's okay with you. All right, so that's the modus operandi for today. So let's start our presentation as such. So you all know what is a machine learning model. So you take the data, dump the data for an algorithm, and then it gives out a model for you, a machine learning model. Um, so I don't have to explain this slide because you already know what it is. And so typically there are 4 steps in building a model. One is data preparation. Obviously, you need to get data from multiple data sources. It's very rare that you will have data given in a very structured format. Um, like like what is done in your coursework. I mean, typically a data set when you take from Kaggle or Analytics Vidya or some other site, um, it's typically given to you in a very clean format, and it'll be in an Excel or a CSV format that you could immediately use. Unfortunately, that is not true in real world. You may have to work on a lot of SQL, or if you're fortunate enough, you'll work with a data engineering department that'll help you to source the data from multiple data sources. Even when they source the data, they'll give you the raw data, and as a data scientist, it will be your job to kind of ensure that you have the required foreign keys in the multiple data sets as such. And then you need to ensure that all the data comes into one CSV. One of the things you would have observed is most of the algorithms or the ensembles that you've created during your coursework, they expect your input data to come through in one CSV file or an Excel file or in a JSON format. So obviously, whatever columns and rows are there, you need to merge all of them and get it into one single place as a CSV file. And that itself is a huge task. And it sometimes, if you have small data, absolutely fine. You can go ahead and work on Excel and you can get things done. However, if it is large data or big data, typically you would rely on using SQLs extensively. So this is one of the tips that I do when I write the SQL queries. I don't try to merge all the data together. Uh, Rather, I will take the small sample of the data and try to see if my queries are working really well. Once I confirm that my queries are working really well, then I go ahead and apply it on the larger data set, because I already know that they work really well. This helps you in two different ways. One is when you have large amount of data, the queries themselves will take a long time in order to get the joins done and stuff. So you will end up spending a lot of time just running your SQL queries. Sometimes it takes days if you have millions and millions of rows, and that's the reality. That's the amount of data that is available out there in industries. So therefore, it's always suggested that you take small samples of data, maybe 100 records or so, quickly write the queries to merge the data and to perform the joins. Test your queries on that small sample that you have picked up, and then once you get the joined file, you verify manually if you've got the output that is expected out of your queries, and if you're happy, then you're good to go in order to run those queries on the larger data set as such. In fact, this is not a technique that is applicable only to data preparation stage. Rather, it is a technique that you should start applying to almost all the steps that is involved in building a machine learning model as such. Um, so if you're building a model, build it on a small sample and see if it works. If you're doing feature engineering, do it on a small sample. Everything you can do on a small sample first, just to get an understanding to see if your code really works well or not. Otherwise, you will end up in a situation where you write a line of code in Jupyter Notebook, but endlessly wait to see if it works or not. That's not a suggestible thing. So that's the first step, which is data preparation. Again, I'm not sure during your coursework you had an opportunity to uh, go through the unstructured data yet, like text documents or images. Obviously, your data will not only reside in databases, you will have a lot of times where your data resides in unstructured formats in other places as well. Um, so you should have those techniques implemented. For example, you may wanted to convert your text documents into something called as bag of words, which essentially is converting your text document into a structured format. Or if you have image file, you can go ahead and convert that image into RGB pixel numbers, which essentially is again converting your image file into a structured format. Once that is done, the next step would be feature engineering. There is a lot we will be talking about it today. So let's park it for now. So feature engineering can range from just eliminating the non-required features, and also it is about creating or engineering new features as such. So we'll be talking about the filtering techniques, the wrapping techniques. We'll also be talking about the feature selection techniques, as well as what libraries are available in order to create new mathematical features. Those are the aspects that we will be covering. And post that, once your data is ready and it's all cleaned up and everything is there in the required CSV file, then comes the most important thing. I'd like to pause and ask you a question here. What is no free lunch theorem? You can type it in the chat box. I'll pause for about 15-20 seconds. What is no free lunch theorem? Yeah, if you don't know, that's okay, man. You don't have to do a Google search. Shailendra Singh, I'm not sure if what you're saying is right. Nothing comes without investment. No, that's not what no lunch theorem says. Ankit Kapoor says trade-offs. You mean trade-offs between our bias and a bias trade-off? Is that what you're saying? I'm not sure. There is no standard algorithm. Yes, Ravi, thank you. That's correct. There is no standard algorithm that fits all the data sets. So essentially what it means is even so let's assume that a bank like JP Morgan is building a attrition prediction model for its customers. So you have the customer base with which your bank has built that model. Can you actually take that model and deploy it in ICICI Bank, which is also in a similar business? What do you guys think? Type it on the chat box. Birendra says yes. Yes, we can see. Yes. All right, Kunal also says yes. Unfortunately, the answer is no. The reason being the environment factors that are there in ICICI and the employee conditions that the customer conditions or employee conditions within ICICI is very different from JP Morgan. So even though it is for the same use case, there is absolutely no guarantee that this model is going to rightly predict the employee attrition in ICICI. It may, if the conditions and the kind of data that is available in ICICI is very it's absolutely same as JP Morgan. But if even if there are slight differences in the features that that are being used in ICICI, then the model will not work. So typically what it essentially means is every time you have a data set, you need to basically do the entire exercise, right? Another question I wanted to ask you is, let's assume what's imputation? Can you guys type it on the question box? What do you recollect when I say imputation? Yeah, I'll just pause for 10 seconds. What do you mean by imputation? If I use a term called imputation, what do you recollect? Mm-hmm. All right, no answers. Imputation is the process of replacing missing values. So your data set also comes with missing values, right? So it's one of the pre-processing steps. So what are the different ways in which you can impute the data? Yeah, so I'd want answers here. Please try to type in your chat box. What are some of the ways in which you can replace missing values in your data set? Hello, all of you with me? I don't have any answers. So I'm just wondering if I'm audible to everybody though. Okay, so let's assume there is a column called age in the data set. And if I see that age is missing for a number of customers, then how do you go about replacing those missing values? Would I eliminate those records from? Yeah, somebody is typing now. I think I have a problem with seeing your answers. Yeah, some Sudhakar says replace the value with mean. But mean is mean. Fill NA is the command to fill the missing values. That's right. Kunal says mean. Thank you. Replacing that with mean values. Yes, that is right. But is mean the only way to replace the missing values? Some Kunal again says you can replace it with median. Yep. Yeah, obviously we need to check how much data is missing from that column. That is, Gundappa says how much data is missing from the column is the first thing that we need to check. Yes, that's right. If you see that more than 70% of the column has missing values, then there is no point including such a column in the modeling exercise. Rather, you would want to eliminate that particular column. Yes, mean, median, mode, or three different ways in order to replace the missing values. But have you ever thought about it? Which will give the best machine learning model? So let's assume I have replaced all the missing values in the age column with the mean, and I have created another data set with where I had all the missing values replaced with median, and I had another data set where I had replaced all the missing values in the age column with median. Now, if I build a machine learning model, which one will give me the better model? What do you guys think? Just type it. Now I have three data sets, one with mean, one with median, one with um, mode. So which one will give me the better results? So Varun says median will give me the better results. Amit Gupta says median will give me the better results. Okay. All right. I think mode will give the better results, although we need to understand the data set. All right. All of you, yeah. Somebody said it depends. Yeah, that's the correct answer, because unless you actually create the model, you don't know which one gives you the best results. So that's the tricky part in data science. So every decision that you take has an impact on the model, and moreover, the interactions between variables is something that creates better models, not an individual column in itself. So nobody knows the answer. In certain cases, mean might give you a better model, median might give you a better model, whereas in some cases, mode might give you a better model. And it depends on the use case also. Uh, so it's not, there is absolutely no answer, and nobody can absolutely guess that, okay, this is the way you need to replace the missing values. In fact, some people come up and say that you need to do k-means clustering kind of technique, or you need to do regression kind of technique in order to replace missing values. So all of those are choices available to you to perform replacement of missing values. But what impact it creates on the model is something you need to empirically test and then confirm. Unfortunately, this is not what you get to see when you do a machine learning model in your coursework. Uh, so you know that, okay, these are the techniques. You also know that, okay, this should be completed within a certain period of time. So what you will do is you apply one of the techniques and get the project done. But when you actually do a machine learning model in production, or in an industry situation, people will ask you, why have you done it? Why have you taken mean instead of median? Why have you taken median instead of mode? So you're, if not your business folks, at least your technical lead is going to be asking you those kind of questions on, why do you think mean is the right choice for this particular missing value replacement? Why do you think mode is going to be a particular choice? So you need to be empirically proving to them, saying that, look, with mean I have created a model, with median I have created a model, and mode I have created a model. Once I have created all the models, this seemed to be giving me better results. Therefore, I have accepted it as the right way to create the model. So that's how you need to approach that particular situation. Uh, so model building is not straightforward. So uh, typically you may have to reiterate the model building exercise multiple times, and that's what you see here in the next slide, which says it is a model building is a highly iterative process, very, very highly iterative process every time. All right, somebody says it all goes by the domain expertise to choose the right way to replace the missing values. Right. Domain expertise will not guide you in terms of how to do missing value replacement. They might, I mean, if you're approaching a domain expert, he might tell you, okay, do it with mean. But that is out of intuition. He will say that do it with mean. But how do you prove that it is going to be, it is the right way of doing it? Um, Erico, I'm sorry, I am not sure if I'm okay. I think it's Arul, right? Arul, I don't know if this is the right way to go about. I mean, if you listen to everything that the domain expert says, then you might end up building a bad model. So just don't go by in what anybody says. Rather, you need to experimentally prove that okay, this is how things need to be built. Okay, a mode is the only way when data is categorical. Yeah, that's right. Gundappa, yes, that's correct. That's correct. Can we use data distribution? How DTA is spread, data is spreaded to decide what to try first? Yes, yes. Those intrinsic details need to be tried out. Yes, that's right. You can do a histogram, and after that you can decide which one. But that is what a mode is doing, right? What will you observe from a histogram? You will typically observe that which one is having the highest frequency, and probably you're replacing the missing values with that particular highest frequency thing that you see in the histogram, and that's what a mode does when you do fill NA. All right, so we'll park the discussion for now on missing value replacement, but the whole idea is there are multiple ways in order to accomplish certain goal, and nobody has the right answer in terms of what will give you the best model. For every data set and for every technique that you adopt, you should go ahead and create a model yourself and identify whichever gives the best result and accept that particular technique as the best technique for your particular experiment or data science project. So therefore, it is termed to be a highly iterative process. And there comes another problem. Can you all type some machine learning algorithms, supervised machine learning algorithms that you've gone through so far? Right? I can, yeah. K nearest neighbors. Yep. Logistic regression. Somebody type linear regression. Yeah, that's typically a regression problem. Naive Bayes, random forest. Okay, support vector machines, right? Decision trees. Yep, great, absolutely great, right? Now there is individual algorithm, which is you can apply logistic regression maybe and decision tree maybe on a particular problem. But there is also ensembles, right? You can combine algorithms and you can get a model through. You can combine one algorithm, two algorithms, three algorithms. Yes, some Deepa Shetty says ensemble techniques. There are 4 different ensemble techniques: bagging, boosting, stacking, and randomization. You've already gone through random forest, which is a technique that is randomization. But you can do bagging with logistic. You can do bagging with k nearest neighbors. No, I don't think bagging is possible with k nearest neighbors, but it is possible with naive Bayes. It is possible with SVM. And boosting you can do with ADA boost, XG boost, cat boost, light boost. So many different algorithms are available, and you can do combination of algorithms. You can do combination of 2 algorithms. I can take weighted average of predictions between k and n and linear logistic regression. I can do a weighted average between k nearest neighbors and naive Bayes. I can take k nearest neighbors, logistic regression, and naive Bayes. I can prioritize k nearest neighbors to 0.7, whereas I give lesser weightage to logistic regression prediction and naive Bayes prediction to 0.1. Yes, we can have a combination of ensemble techniques too. You can actually combine the results that you get from ADA boost as well as bagging as well, right? So the number of combinations that you can do is really enormous. So how do you know which techniques to try? Yeah, I'm expecting an answer from you guys. So if there are so many different ways to actually, yeah, Avinash says grid search CV. That's a different problem. I'll come to it in like a couple of seconds from now, right? So just by better understanding, Birendra says, by better understanding of how algorithm works. Unfortunately, that is not true. What you actually understand what you actually learn when you actually delve into an algorithm is learn the mathematics behind that particular algorithm and understand how the algorithm works. However, what algorithm works much better in a particular situation is not something that you can decide beforehand, even without experimenting. You have to experiment with each of the combinations and identify which one is the best model. And that's where the problem is. Yes, cross validation, obviously you will do in order to identify which one is giving you the best performance, right? Yeah, precision, recall, and all of them are best metrics. Yeah, result is nothing but performance metrics, right? Precision, recall, accuracy, area under the operating curve, F score, a simple plain accuracy or weighted accuracy, all of them are several different metrics. You will decide on the best model based on whichever model gives you the best accuracy. That's absolutely correct. However, creating the model itself is a very painful process because there are so many combinations available, and as part of your data science job in an industry, you are expected to create so many of these combinations. But don't get disheartened. I have an easier way to do it. Okay, I'm going to reveal that secret sauce in just a couple of minutes. Okay, but Shailendra Singh also talked to me about cross-val. No, no, Avinash Java also talked. I love your last name, man. Java. Good. So Avinash, um, so yes, Sudhakar, you stole the thunder from me. Yes, I'm going to talk a little bit about teapot, not exactly teapot. I'm going to talk a little bit different. Yes, Avinash, I get it, but still it's Java. Um, so grid search CV. The problem now is each of these algorithms will best perform when you actually set the best hyperparameters. What are hyperparameters? Can you just type in here? What are hyperparameters? Mm-hmm. Tuning the parameters for an algo. Right. Parameters we override. So basically, parameters in control. Yes, Shailendra Singh, Sudhakar, Nagapavan, and Ravi, all of you are all yeah, all of you are all correct. It is configurable. Yes, that's right. So basically, you can configure this hyperparameters and you can tune an algorithm to create multiple models using different sets of uh, hyperparameters. You test for various hyperparameters and get the best output from the algorithm that you build. The problem is when you have so many combinations, to make the situation worse, there are so many hyperparameters also. So if I have decided to use support vector machine, random forest together in my ensemble, so there are definitely two algorithms, but each one of them has 10 different, I mean, 4 different hyperparameters each. So look at the number of combinations that are required in order to build a model. So it's a lot of models, right, which you will have to create, because at the end of the day you want to deploy into production in your industry scenario the best model possible. So it's a search in the universal space for the best model possible and the best hyperparameters possible, and these hyperparameters, this model performance also depends on how do you treat your data with various techniques that are there, and it also depends on the feature selection that you do in the data set as such. So therefore it's not one single thing that impacts your model performance, it's everything, right from the techniques that you select to clean your data till the hyperparameter tuning, everything impacts your model performance, and what you need is the best model, and it's a search, never ending search to get the best model out of all the possible models out there. So sometimes you might feel it like searching for the best girl in the world. It's absolutely difficult. One of the models could be good at one thing, and another model could be good at another thing. So it's extremely difficult. Nagapavan, thank you. It seems like you like the joke. Right. So I'm going to leave out all these challenges at this particular point in time, and I will be delving into each of the techniques individually. And I hope all of you have got a good motivation on what this lecture is all about. So far in your lectures, what you would have learned is, or what you would have learned is, you would basically split your data set into training data set and test data set, and you build a model that is performing really well, and your work stops there. But in an industry situation, your work doesn't stop there. There is something called model deployment. The idea of creating a model is to have your data, your future data pipelined into the model, therefore it can be scored. So it's like this: you watch a movie for 3 hours, you understand the movie, and after the movie is done, I'm going to ask you questions, and you need to recollect from your memory, and you're going to tell me the answers from whatever conceptualization you have got from watching the movie. So the model building exercise is all about watching that movie and conceptualizing the theory of the movie. And now when I ask you the question, which is the data that is flowing from future, you need to actually score the question and give me the appropriate answer. That is what is expected. So there is that conceptualizing phase that you have already learned in the course, but there is also something called as productionizing phase, which is more like me asking the questions and you answering those questions, which we'll be learning today after covering all of this bigger things that are there in the training phase. All of y'all with me? Say yes if you're with me. Yep, very good. Thank you. All right, so just give me 1 second. I'm going to do a full screen here. All right, so we've already spoken about data preparation. Obviously, you collect the data from multiple data sources. The data sources could be structured. When I say structured, it is in a table format. You can directly extract it. But unfortunately, in an industry, the data is scattered around multiple places. For example, the call center nodes, the number of calls a person has done to your call center is in the call center database, whereas the actual location details of the customer is in another sales database that is held by the sales team. And the invoices database is going to be with the finance team. So if you are doing a model in terms of predicting whether a customer is going to renew a contract or not, all these details are required. And you need to collate all these details and put them into one single CSV file or an Excel file, and that in itself is a task, because you need to coordinate with multiple departments. This is an interesting question. I want you to think for about a minute. Why do you think call center details are important for predicting if a person, or if a particular business is going to renew their support contract next year? How is that going to help? Call center data always follows Poisson distribution. I am not sure, Gundappa, about that, but I wanted to. Yes, call centers are directly facing with customer. That is right. But how is that signal going to help me to predict if a person is going to renew the contract for next year? Sentiment analysis, yes, that's right. Can you expand on that, Sudhakar? And can you also expand on your answer about number of calls, Gundappa and Ankit Kapoor? CSAT scores, no distress calls. Yes, uh, Sachinanand Rai. Sorry. Yes, you're right. But can you all actually expand the answer? Customer happy with call center support is not based on customers making a call. Yes, therefore you need to do CSAT survey. The time it takes to resolve a call is an indicator of performance. Okay, so let's assume I am a company called SAP, and I want to build a model. um, Yeah, you're all right. Let me explain the answer for it. If I am a domain expert curating the features to build a particular model like this, and if I'm a business like SAP, obviously I sell my product to you guys, to various businesses, and based on my model, I wanted to give a rebate on renewing the support contract to various customers on a yearly basis. So call center details are absolutely important for two reasons. Number one is because if a person has already bought a support contract from me last year, but he hasn't called me even once, that essentially means either my product is working too well, or he never got in touch with their customer service because he never was able to get through to me. And there was some problem with the numbers that we have given to him, right? That's one thing. Or he has made less number of calls because he was not happy with the number of calls he has placed. That is another thing that you can actually he has placed less number of calls, and he is not encouraged to report more issues to me because he was not happy at all. Another problem is, uh, our lines are always busy. Our support desk is very short staffed, therefore they were never able to reach us. So these are all indicators that that person is not going to renew the contract. So what will you do as a SAP business? You are not going to stop from there. So the moment you know that this customer is not going to renew the contract, you're going to offer some interesting discounts, or you will have your customer service manager talk to him and check and ask what is the problem, are you not happy with me, etc. So you need to have some domain expertise in order to curate these kind of features. It's not that somebody from business is going to help you to create these kind of features. These are great signals. You need to absolutely know what your business is in order to create these features. Can you all ping me certain features that can help to predict whether a customer is going to renew his support contract or not? Yeah, try to ping me here. The question is, I want to build a predictive model that predicts if a business called X is going to renew the contract. Sales numbers, I've already sold the product. There is only one product. Repetitive calls, yes, again, call center thing. Customer service, recursive calls, all of them are, yeah, second year discount given to customers. Number of defects in the product, yes. Performance of the product, yes. What other things? Feedback from customers, somebody has told me. Yeah, think a little bit more. It's not only about call center. There are other things that will affect. I want you to think a little bit more. Word of mouth, they have already bought our product. I don't know if they're going to talk more to see if product is good or bad. Client sales numbers, so how much they were able to get benefited from, I mean, how much they were benefited from our product. Yeah, definitely. Industry condition, Ankit Kapoor, excellent. That was the answer that I was looking at. So if it is recession kind of condition, do you think they're going to renew the contract? Very less number of chances. And if they have attrition, or if they got if they got acquired by a different company, they may be replacing our product, right? So, or if somebody said macros, Deepa Shetty, I think Ankit Kapoor again said macros. I think you meant they are building some product internally which is similar to our product. In that case, also they're not going to be renewing our contract, right? So this is how you need to think when you are building a product, right? Net promoter score, yes, but again, that is a survey thing that you take. It could be a good signal to see if they're going to be buying our product or not. Yeah. So when you actually get a problem, you need to sit down and think what are all the features that I can create. So these are all absolutely business features. Most of the time, what you need to think about is what are all those features in real world, and by my common sense, that will help predicting whether somebody is going to create the somebody is going to buy my support contract, and then you include them as columns in your data set as such. Another thing is, okay, so this is one of the problems that we typically get. We get the data set dumped at us, but we don't know which columns are useful or not. How do you determine which columns are useful or not? So most of the times when in an industry situation, what happens is data gets dumped at you. Yeah, PCA, Nihar says PCA, but PCA wouldn't help you to eliminate the features that are not required. What it does is it does some kind of condensing of features. We'll talk about it. Featureization is about creating features, which I just talked about, feature engineering. Correlation, uh, backward selection, yeah, what you're actually talking about, all of it is feature selection techniques. Okay, but think about this in real world, in an industry situation, nobody tells you the problems. Most of the times it is very sure that when you join a startup, they'll just say we have this data, go figure out the problem, right? Even if you join, yeah, Piyush is nodding his head here, sitting next to me. I think he has the same problem with great learning. So some data got dumped at him, and he was told, go ahead, figure out the problem and solve the problem as a data scientist. Yes, all of you are talking about feature selection techniques, but observe my answer there. First, you need to figure out what problem you're going to solve. Say, if I have given you a data set of last 10 years, which consists marks of students in graduation examination in Bangalore University, then there are different problems you're going to solve. One problem is, what is the percentage of pass and fail? Is it incrementing or decrementing? Then all the data that is required is just that column that says pass or fail. You don't need rest of the data. Or if you wanted to identify which college is best performing over the last 10 years, then what you require is pass percentage, right? And the problem can be interpreted in two different ways. How do I actually say a college is best performing? Is it based on the pass percentage, or is it the number of ranks that a college has got? So there are two dimensions to the problem. You need to finalize that problem first in order to identify which of those records are important and which of those columns are important. Or if you are thinking about which college has got 0% results consistently over a number of years, which are those colleges that I need to penalize for, then the data set that you need is absolutely different. So there is no one answer for it. When you get a data set, first see if you have the real problem described to you. Most of the times, a business analyst will come and ask you, can you do a flying car out of this particular data set? He will give you the sales data set, and he will say, I want a flying car right away, right? And it's your job as a data science to say, dude, look at this data. This is sales data, and what you have given is a set of records of the sales that I've made last year, and the number of the columns are there. It is absolutely nowhere correlated to the flying car that you're asking. That's a different thing. So don't get carried away by whatever you see on internet, and then you need to get him onto the ground. Some people will say that they'll give you sales data and they'll say that I want to increase my sales by 200% this year, do something, right? They will say that. And you cannot guarantee such output from data science, right? It depend, your sales increase is going to depend on multiple things. Therefore, you need to get them grounded, saying that, you know what, these are all the possible problem statements that I can solve with the data that you have given me. One of the things that you can solve when he gives you the previous year sales data is, probably if you have prospect database, I can identify those individuals that have more propensity to buying from your data set. So what I built there is a lookalike model. So I look at the customers that have bought the product with least amount of advertisement from the earlier data set, and I will build a model to look at all the prospect database and match those people that have very similar traits of people from the sales database that have bought very easily. So it's a look-alike model that you can build and give it to him. Or you can refine the problem statement to say that I can give you the details of all the customers from your prospect database, uh, and those individuals will be the ones that will make high number of sales or high amount of sales, which will indirectly contribute to your revenue. So the data preparation step is not just about collating the data and merging the data and having one data set that you can feed into the model. Rather, it's also about getting a clarity on the problem and getting your stakeholders grounded, because they think data science is a magic whip or magic stick that will create wonders. Unfortunately, it is not. It is just a little bit of math and stat, and it's a set of algorithms that is going to work on data, which will give you more insights into your data, and that's going to predict with more intelligence on which is your better customer. So that's all it is going to do, and it's your job as a data science during the data preparation step to tell them what a particular data can solve and what it cannot solve. Flying car, definitely no with sales data. All right. I hope all of you are still with me. Say yes if you're still with me. Wonderful. Wonderful. Thank you. Right. The next thing, the next challenge that we're going to face is, most of the time they want to solve a problem. The business stakeholder will come and say that I have this particular problem. But according to your intuition or common sense, you will say that this may be the kind of data that is required to solve this problem, but the data is never captured in your organization, right? For example, a hardware company wanted to predict when a sensor in a lift goes bad, right? And it is a proprietary sensor that is made by that particular company, right? And it's a typical time series problem, right? You see, you backtrack, you have data for the last 10 years in terms of how that sensor has failed. Based on that, now you can build a model to say that if I have deployed the lift today, when that sensor will go bad. It's a time series problem, but that sensor itself is released last year to the market, so you don't have any data captured in terms of when the sensor has gone bad in the market. I mean, in the previous years. So you absolutely don't have the data. So in that case, you cannot solve the data. So I mean, you cannot solve that problem. So what you need to go back to your business team is, you know what, this is what is the data that is required. It is not there currently present in our organization. Go ahead and capture the data. That is something which you need to establish with your domain folks. And what they will do now is they will start capturing the data. If the project is put on hold, they'll come back to you next year with data set and say, look, we've captured that data, go ahead and rebuild that. These are practical problems that you will face in almost all the corporates and as well as startups when you actually try to deploy deploy your data science knowledge there. Okay, so data preparation, I have already spoken to you briefly about it. uh, yeah, sit with business team and understand the problem and then look at the data is what Kundapa says. But the problem there is business team has very less knowledge on sometimes business teams will have lesser knowledge on artificial intelligence and ML. They don't know what it can create. So they look up to you to get that clarification, right? So you need to be the flag bearer of what it can accomplish and what it cannot accomplish, right? Uh, so there is structured data, unstructured data. You know how to convert unstructured data into structured data and then combine all of them together. So again, there are multiple techniques there. Do I represent my document with bag of words, or uh, do I do word to egg, or do I do fast text, or do I do glove kind of embeddings? All of these are choices. See, all of that. Think of all of that has been taught in your course as weapons in your bag. and you need to use the appropriate weapon at the appropriate time. But the problem with um, data science projects is you need to use the weapon and figure out which is the best weapon that works at that particular situation. So you need to try out all the weapons that you have learned for a particular problem, and then see which one gives you the best results, and that is the best weapon that you need to carry out for the final productionized model. So that's what I've been talking about for the few uh, for the last 1 hour, right? So it's 11 o'clock. We will now jump into the next step, which is feature selection. So I just want to show you some code snippets as well here. So it gets you a briefing. Um, yeah, Naga Pavan has a question, but it's in case. Yes, yes, lot of combinations are needed. Therefore, that is the job of a data scientist to figure out which is the best combinations. Yes, there is going to be a lot of combinations, but there are some interesting techniques which I'll be talking in few minutes. So from 12 to 1, I'll be talking more about the solutioning mode. Now I'm talking about the problems that exist in data science. So at 12 o'clock, I'll reveal the secret sauce. How much data size is required for modeling? Very good question, Birender. Um, See, one of the challenges that we face is not much of the data is available. Sometimes the data is available, but it is very less. So if you're predicting high value redemptions from a bank, so look at the number of people that would have done those high value redemptions. Say $1 million is considered as high value redemption by your bank. So how many people would have done that kind of redemption in the last 1 year? Very less, right? So when you have less amount of data, what do you do? I'm looking for answers. What do you generally do when you have very less number of uh, records? Synthesize the data. I'm not sure. Sudhakar, did you mean create synthetic data? That's what you said. Get the data collected. That's a Shailender. That's a good option. Yes, duplicate the data, but how? What? Tell me the name of the algorithm. Tell me the name of add a boost. No, add a boost doesn't do it. I don't know about IMB learn. No, bagging and boosting doesn't do it. Yes, Yogesh, you're right. SMOT, synthetic minority oversampling technique. So that is the one that I would typically use. If yes, Akshay, that's right. Yogesh and Akshay, you guys are right. Use techniques like SMOT, and so Shailender, you also talked about. I think it's Shailender that talked about getting the data collected. Yes, that's right. Um, so there is a new area that is getting really picked up these days, which is called human computing. I want you to have a look at a website called Amazon Mechanical Turk or Crowdflower. These are certain websites that will get you cheap labor for tagging your data, right? So just have a look at these sites. Amazon Mechanical Turk. Yeah, thank you, Piyush. Yes, we are typing it, Sudhakar. And the name of the other site is Crowdflower. No, just Amazon Mechanical Turk and uh, Crowdflower. We're typing, but for some reason it is not just getting broadcasted to you guys. You can search Google. It's Amazon Mechanical Turk. Yeah, got it. And the second site is Crowdflower. Flower as in, you know, the flower that's there on the plant. Yeah. Yes, Crowdflower. Yeah, that's right. Deepa Shetty, that's correct. So have a look at this site. Yeah. So Sri Harsha, maybe you're right. I maybe it got acquired, but last time when I looked at it, it was called Crowdflower. Sure, Google will help you to find out. There are lots and lots of sites that are coming up. Basically, these are sites where you can outsource your data to, and then there are APIs that will randomly allocate each of the record to individuals that are cheap workers in third, uh, in poor nations, specifically in Africa and stuff. And what they do is they actually uh, look at your record and they'll tag appropriately. Say, uh, so think of it like this. How many of you have tried CAPTCHA, right? So when you're doing CAPTCHA, what you're actually doing is you're deciphering a uncomprehensible text to something comprehensible. So that's the application of human computation. So people are increasingly outsourcing tagging or labeling kind of tasks that can be used in supervised machine learning to sites like this and getting the data tagged. And once you have the data, enough amount of data tagged, you can build a robust model, right? Another phenomena that is getting increasingly picked up when low amounts of data is there, specifically in deep learning area, is something called transfer learning, right? Have you guys heard about this term? Yes. Okay. Sudhakar Reddy says yes. So specifically tasks like image recognition uh, or uh, uh, I will repeat. Rajesh Jain, what is the topic you want me to repeat? You mean the topic called transfer learning? Rajesh, is transfer learning? Okay, yeah. All right. So transfer learning typically is somebody has pre-built specialized models in tasks like image recognition and digit recognition, as well as identifying names of people in a given text. So those generic tasks have been trained on millions of data sets. I mean, they've taken documents like documents such as Wikipedia, which are, is it transfer learning? Yes. Gundappa, yes, I'm talking about transfer learning. Right. So transfer learning is a phenomena typically used when you have scarcity of data. Basically, what you do is you take a model that is pre-trained. So, and then you apply to your particular task. Say, for example, you wanted to identify digits on a number plate of a vehicle. You don't have to rebuild the model. There is a model that is already built and that is already available on the model zoo. You can search for it and you can download that model and reuse it. And if you have studied about word2vec, that is exactly what you're doing. Um, you don't actually build your model uh, model. Rather, you would download your Google pre-trained model from their site and you will use it. Of course, you have an option to build your own model to identify your text and then to create embeddings from your text. But with the amount of data generally organizations have, it is absolutely not possible to generate a good model. Therefore, what we typically do is we go ahead and reuse the model that was already built. Think of it more as reusing a library function that is already built by somebody. There is an API that is built by somebody and we are reusing it. Okay. So um, Ankit asks, what is the actual sequence after the pre-trained model is downloaded? So once you have the pre-trained model, you go ahead. Yes, these models are all open source and it's absolutely free of cost. You can use it. Have a quick Google search on image recognition pre-trained models. You will see n number of them. Um, Companies like Google, Microsoft, companies like Amazon are repeatedly coming up with these kind of models. And day before yesterday, there was a company called OpenAI. Uh, my voice is breaking, Rajesh. Is it the same for everybody? All right. I think it's a specific problem with you, Rajesh. Maybe your internet is bad. Rajesh, if it helps, maybe you can log out and log in once again. That'll help. Okay. Anyway, so have a quick Google search on right. Have a quick Google search on these topics that I have talked about. One of the things that you can look at is Amazon Mechanical Turk, Crowdflower, as well as pre-trained models. What you typically do is you download those models that are already available, embed it within your Python code, and then you score your data. You don't have to retrain it. In certain cases, in deep learning models like CNN, what you can do is you can have a pre-trained model downloaded, and you can check out the last layers to identify faces of individuals or digits in a number plate, etc. You can check them out and you can customize it. Say, for example, there are number plates written in English, and the pre-trained model can only recognize English digits, whereas you can retrain the pre-trained model. Observe what I'm saying. You can retrain the pre-trained model that is downloaded from internet and make it identify Kannada digits, or you can make it identify Hindi digits or Sanskrit digits, right? So if you actually look at a neural network, the initial layers are more about identifying where in the number plate the digits are located, the color of the digits, the intensity with which the digits have been written, all of them. Irrespective of whatever language it is, the layers, the initial layers will remain the same. And what you're going to retrain with your small data is just the last layer that identifies the digit on the whole, right? Therefore, you can use the same English language pre-trained model and use it and customize it to recognize other language digits also, right? So that is one phenomena that is increasingly being used. I forgot the person that actually asked me the question, well, what to do when you have small data. So these are all the techniques that you can actually follow. It's 11:15. Birendra, thank you. That was a very good question. It's 11:15 now. I need a small 10-minute break. We're going to come back at 11:25 and rejoin. We're not going to disrupt the GoToMeeting. It's going to be as is. You go ahead and have a good coffee break and come back. We'll see you after this break. Thank you. Hey, Rajesh and Bandana Kumari. No, the session is not over. We're on a break at the moment. We're going to start in a couple minutes, 2 more minutes. Yeah, we took a short break of 10 minutes. I was very tired speaking for last 1 hour. So I'm just having a hot coffee. I hope you're equally tired listening to me for the last 1 hour and you're having a hot cup of coffee there. So I was just telling Piyush that this is more like doing a radio jockeying job. Yeah, it's interesting. This is my first webinar apart from my corporate job. Teaching online is very interesting now. So I say I can make myself a good radio jockey and an alternative career for me. What do you guys think? So can I make a good radio jockey? You've been hearing from me for the last one hour, so I'd need to get some feedback. Oh yeah, Rajesh gives me a big yes. Thank you. Sudhakar, I can speak Telugu, so I can join Radio Mirchi. Yes, Akshay, yes. I will do that. Podcast definitely. Amit. Yes, of course, you have good sense of humor with technical jokes, right? Machine learning on Radio Mirchi. See you after the break. Yeah, that's a good one, Birendra. So, um, Amit, you actually typed the answers in the same location where you just typed this comment. That's it. Yep, I am back to Ankit. Will just give me 1 second. I'm here to start. Okay. All right. So hope all of you had a great break. We will be carrying on with our session. In the last session, we discussed about what are all the problems that we encounter while building machine learning projects. And we also talked about what are all the typical challenges that you would have when you're prepping the data for your project. So for now, all that problems aside, we've got our stakeholder grounded. We told them what is possible and what is not. We told them we cannot build a flying car out of the sales data, and they now have right kind of expectation. And we made one CSV file um, out of the data that has been collected from multiple data sources. And we already know how to get more and more data if at all there is scarcity of data, right? So we rely on platforms like Amazon Mechanical Turk or Crowdflower, or we rely on things like transfer learning to build good models, even though we have small data as such. So the next step of typically in industry would be to take the data and cleanse the data. So there are multiple terms that are typically used in industry to explain this term called cleaning the data. So one is data munging, right? So one such term that people will talk to you about is do data munging, or this is the job that most of the experienced data scientists hate. And if you're more than 5 years experienced in data science, you would typically outsource this job to all those interns that join from IITs to clean your data and to give you that file that is all cleaned up. Therefore, you can right away move to the modeling stage. So unfortunately, this is part and parcel of your job if you were to join a startup. So nobody is there to help you. You are on your own. So if you're unfortunately a individual contributor titled as a principal data scientist, or if you're in a startup, you're on your own. Take the data, do all the data munching tasks. It's very difficult. It's very tedious. Um, but at the same time, it is a mandatory task prior to moving to modeling. Okay, so I'm pretty yes, Sudhakar Reddy, yes, fill NA is part of data cleaning. Yes, query your data slide. I'm seeing. Yes, sir. I'm moving to the next slide. Yeah, here you go. Mithun, how about you? Do you see the clean data slide now? Midun Srikanta? Yep, very nice. Sorry, it was my bad. I didn't move to the next slide. So the first thing is to identify if your data has the right thing that you thought it will get you get you. You would have written certain queries to pull the data from certain databases, right? So you need to first ensure that you have the right data in your CSV file. When merging the data from multiple Excel data sheets or multiple CSV files, uh, sometimes the data gets corrupt. Sometimes while pulling or sometimes while creating that CSV file, the data gets corrupt. Some uh, weird looking foreign characters get imbibed into your data set. All of this will create when you pump your data into Python. So if you have those non-ASCII characters, uh, yes, sir. Yogesh, we will come to imputation techniques in some time, but for now, I'm specifically focusing on what are those things that you would have to observe when you get the data set. So I'll come to your point in a few minutes. All right. So one of the first things, as I was telling you, is to observe the data and make sure that what you thought is the data required for the project is in there in your data sheet, right? And apart from that, these weird kind of characters such as non-ASCII characters will cause a lot of problem while building your model or while pumping your data with read underscore CSV command. Um, it creates absolute lot of problem. So yeah, incorrect date formats, all of them are integral problems. Yeah, you're right, Sudhakar Reddy. Incorrect date formats is one thing that you need to look at. And then you also have to look at time zones. If your data is pulled from two different servers, one server is located in Asia and another server is located in America, for example. When you merge the data, the current date in Asia is going to be today's date, whereas in America, in one part of America, it is going to be yesterday. So if you want the current data, then you need to put yesterday's date in your query, not today's date. So those kind of things also you need to look at. And um, comma separations and all punctuation symbols, most of them will cause a problem. Percentages will cause a problem. Hashes will create a problem. At symbol will create a problem. So you either need to tweak your read statement in such a way that it ignores all these punctuations and still load the data into your RAM, or you will have to apply some regexes. When I say regexes, it is actually regular expressions, right? You need to actually do regex on your data set so that all these punctuations and other non-readable characters are eliminated from your text. One of these pre-processings is absolutely required, right? Another thing that I would typically look for when I get the data set is how many missing values do I have. If I have missing values more than 70%, I would eliminate that particular column in itself, right? So I would have a notebook by my side. I will typically go ahead and write down all the columns. And when you get the column names from the database initially, you would see them written in database language, as in whatever the DBA wanted to name that column as, he would have named it. So, but this will be a bigger challenge for you during modeling because you need to call features by its name. So one of the first things that I would do is read out all the columns, make a note of them in my notebook, prepare a data dictionary. So I will rename all the columns. I will describe all the columns in my notebook. Therefore, I remember what each column means, and I don't have to go and ask the DBA every time, right? So when I get the database, when I get the data from those people, and when I have merged, I'll go validate it with the DBA team, ask them what each of the columns mean, write them in my notebook. Apart from writing the names of the columns, what I would do is uh, I would also ask them about the limits, or what do you call, um, Um, yeah, I would typically ask what are the values that fall into the column, right? Uh, Not able to see notebook. Gaurav, I'm not showing any notebook. I'm still just talking. Uh, are you able to see the slide? Yeah, I'm still on the slide. I don't have any notebooks for pre-processing of data. These are best practices. The code is right away available on Stack Overflow and Google. You can copy paste it. Nothing Greek and Latin about it. So um, yeah, so I would ask them what is the cardinality for the column. So cardinality essentially means what are all the various values that this particular column takes. So for example, if I am dealing with a credit card company, and if there's a column called age, then typically I would like to see the age between 21 years to 60 years, because I know that people get credit cards during this period of time. uh, Rajesh, I think you have a Rajesh, I think you had a problem with your internet. You were showing offline for us also. You just came back online. Are you able to hear me now? Yeah, cool. Very good. You're all set. So typically, I would like to see the cardinality of the age column between 20 to 60. So this knowledge will help me to identify outliers as well. So what are extreme values? What is the difference between extreme value and an outlier? It's very important concept. Yeah, I'm looking for answer. What is the difference between extreme value and an outlier? Hmm. Yeah, outlier is an anomaly. Right. So the typical difference between an outlier and extreme value is, see, though the credit card company issues credit cards for people between 21 years to 60 years, there could be one or two situations where they have given a credit card to a person that is 19 years old, or 61.5 years old, because that person was still working, right? Though those credit cards are issued, these are not people. These are not outliers. These are just extreme values. They are still valid values, but these are not the most common values. Whereas outlier is somebody that is completely out of the game, right? So I see somebody's age as 125, and there is absolutely no possibility that this person gets a credit card. I see somebody's age as minus 61 or minus 60. um, right, so these are all the things. Yeah, there are different definitions to it, but I'm not sure where you have referenced it, Akshay. But the typical definition is, if it is complete outlier or not. Right, if it is a complete outlier, that is when you see there is a plus or minus standard deviation that you would add to the normally possible values, and if it is still within that particular threshold, you will accept that as an extreme value and keep it with you, whereas an outlier is a complete dirty data that you wanted to throw off, or you wanted to do something about it. So when you have outliers in your data, we can do a couple of things. One is, uh, how would we detect that? Do we visit those records and check manually? Yes. There is no one simple and easy way to identify outliers. Uh, right. You typically need to know the ranges of the columns. This comes in exploratory data analysis. Once you understand what are the ranges within which the values fall, you go ahead and query the columns to identify those extreme values. Yes, the box plots, all of them will help. These are all different tools. Interquartile ranges and box plots, these are different tools. It can be as simple as show me all the records which have got um, uh, a value more than the possible range for that particular column. You can write a SQL query and still end up getting those records. So there are two options for you. You can either throw out all the records that are there shown as outliers, or you could go ahead and massage them. When I say massage them, you could go and fix them through regression kind of technique or k nearest neighbors kind of technique. Say, for example, if I have Piyush's age as 125, I know that he's a valid customer. I see other attributes of him are very, very valid. So what I typically do is I go ahead and identify the cluster he belongs to. And based on the cluster, I actually copy the value that is the mode of that particular cluster as his age, right? The most frequent value of age in a cluster that Piyush belongs to will become the age of Piyush. So that's what happens. So that's one way of actually doing it. Bandana, is everybody able to hear me? Because Bandana Kumari says she's not able to hear me. We just want to identify if it is a problem. Yeah, Avinash Java already confirmed he's able to hear me. So yeah, loud and clear. Very good. Bandana, I think it's a problem with your internet. Please log off and log back in. Cool. Thank you. So that is one of the things that we will have to do. There are multiple techniques uh, to do outlier removal or outlier. Uh, yes, Gundappa, that's correct. Miniscove's error and all of these are again distance-based techniques. Miniscove's distance is what is being used there. There is multivariate method as well, but we're talking about individual columns. In most of the situations, what happens is you will not have multiple columns for the same record as null. Rather, you will end up having one column as null. So how do I go about replacing that cell alone? We're not talking about replacing multiple cells. So I'm not sure multivariate methods will help there. That is my perspective about it. And there could be some techniques which I'm not aware of that will still help you to replace that value. But on this slide, I have shown you three different techniques that you can follow in order to replace through regression. All of them are available in scikit-learn library. I'm not getting into more details of it. You can look it up as and when possible. Yeah, Bandana, welcome back. I'm glad you're able to hear now. It may be possible, but extreme values are not that big problem. So what you need to treat for is outliers, right? And after that, there are, I mean, obviously there is scaling that needs to be done on data, specifically if you're building a regression kind of model. Um, yeah, Gundappa, that's correct. The syntax is right. You can do that, or fill.na, and all of those are different techniques to, I mean, different ways of writing your Python, right? So so one of the things that we will also do is to convert a categorical variable into a number representation. For example, if you have sex as male and female and transgender, instead of actually retaining it as is, we may have to represent it as 0, 1, and 2. Why do you think this is important, guys? Why do you think number representation of categorical variable is important? Machine does not understand English. Ankit, okay? For maths to work, algorithm only understands numbers. It has to be numbers. Okay, how many of you have done decision tree? All of you, right? So in decision tree, can you provide categorical column as input? Sudhakar, I want you to try once again. Yes, you could provide categorical column as input. You can just have it as male, female, and transgender and still pump the data into the algorithm. It will accept it. Yeah, Ravi Gondila, yes, that's correct. Right? Whereas naive bias, you guys have tried that algorithm, right? So spam ham classification you would have done as a part of your example, but you will still end up converting your algorithm into and converting your data into numerical format, and only then you would have pumped your data into the system. Why would you do that? Because naive Bayes algorithm is more about counting the numbers. So it expects your input also to be in numbers. So one of the things you will have to pay attention to when learning the machine learning algorithms is what kind of uh, in KNN also we convert and then pump. No, sir, that is not true. You can still pump categorical data into it, right? There are special kind of distances that you could still do to compare the distance between one value to other when it is categorical. Right? So you may not be using Levenstein's distance there or Minisco's distance there, but there are other kinds of distances. I think Watt's distance, Earth movers distance, they all compute distances between two different categorical values. Yeah, whenever you have to perform mathematical operations, we need numbers. Yeah, that's at a high level, that is correct. But there are algorithms that will accept the theory that I'm trying to explain is there are algorithms that accept only numbers as your input. There are algorithms that will accept both numbers as well as categorical values as input. Okay, so that is something I want you to keep in mind. And when you are actually learning one of the algorithms, you need to pay very clean attention, very clear attention in terms of what kind of input an algorithm accepts, right? And in certain cases where your algorithm does not accept any non-numerical values, there is no other option except for converting the categorical values into numbers, and that is what we are doing, right? By default, when I encode male, female, and transgender as 0, 1, and 2, it is considered as a ordinal variable, right? What is an ordinal variable? What is an ordinal variable? Yes, there is a rank, and but unfortunately, yeah, which has rank associated. That's correct. All of you are right. But when I am talking about genders, all that I have done is just encoded this nominal variable into numbers, but I still don't want I still don't want I still don't want my numbers to be considered as ranks. Male is equal to female is what I wanted to say, rather than a female is more than man, or a male is more than female. I don't want to have that kind of relationship. Rather both of them are equal is what I want to say. So what I will do is, instead of actually encoding it as 0, 1, and 2, I would create 3 different columns. One which otherwise is called as one hot encoding. One hot encoding essentially means that you're going to represent each of the values as one single column. If he's a male, he will have a 1 on the column where it says male. The other 2 columns will be zeros where it says female and transgender. So the code is given on this particular slide also. So this is something which you will have to pay attention, and based on the algorithm that you're going to use, you're going to go ahead and create you can't perform algorithm on them by transforming the columns X into, we are increasing the dimensions of data set. Is this a good practice to do? Yes, we will talk about dimensionality reduction in a few minutes. Yeah, so one of your colleagues have already given an answer to that, Saurabh. There are multiple techniques. One is uh, one is singular value decomposition, or other way of expressing that as principal component analysis, where you're going to reduce your dimensions to a specific number of variables. We'll talk about it in a very short duration. So I have the clean data set. No, you still don't have the clean data set. There are other problems that are very interesting to observe. So there is something called as non-interesting statistics, right? What it essentially means is if I have a column called income and everybody, if I have 10,000 records and 9,900 of them had an income of 10 lakh rupees, is that an interesting statistic? Do you still want to retain the column for a particular problem, right? No, you don't, for the reason that it has very less number of values that will contribute to your model. A model is going to look for features that are going to be discriminative in nature. So what I mean by it is, if a feature is going to contribute to separate a particular record into one or the other class, then it is called as a contributing feature, right? If it is not going to help you to put into one class or the other, then it is a non-contributing feature. If everybody is of the same sex, or if everybody is going to be of the same income in your data set, then that particular column is non-discriminatory. So the variance is zero for that particular column or near zero. So look for a filter called, I mean, this is not something which I have included in my data set, I mean, included in my PPT, but just make a note if you have a pen and paper. Look for something called zero variance filter and non-zero variance filters, right? Zero variance filter and a non-zero variance filter. I'm just typing it. Yeah, you're right, Avinash. A column with no variance is not good. But there is a problem here. How much amount of variance is good enough? Right? I'm talking about 100%. Everybody has the same value. 10,000 records are there. All 10,000 records have 1 million, 1 million or more as income. It's absolutely fine. Nobody has. It's not a discriminatory feature. I can eliminate that. But what percentage is good enough? What variance is good enough? Yogesh, that's right, less variance, but what is good variance? Uh, yeah, Ravi, that's like a Viva answer. I'm not scoring you in practicals. No, Ankit, there is no thumb rule like that. Okay, this is not an answer. There is no answer for this question. It's a rhetoric question. It depends on the problem. Yeah, you again gave me the Viva answer. Sorry, no marks for that. Sudhakar Reddy, I got you. No marks for you also, right? So what I was saying is there is no answer. Probably you would want, as a ballpark, you want to have a 60% variance in your data. What you can do is you can create different data sets with different variances retained, and then see how it works, right? So you can prepare one data set called X1, which has the income column with 60% variance, 70% variance, 80% variance, 90% variance, and see what happens, right? So is it possible that a feature in combination of other variables might be good for a model? Yes. I'll give you a very simple example. Instead of representing a triangles, so I'm bad at triangles area. Okay, let me give an example of a rectangle. Instead of representing rectangles dimensions as length and breadth, what can I represent it as? Instead of representing it as two features, I can represent it as area. That's right, right? So now area is a combination of length and breadth. Why should I not do it? It's up to you. If you want to combine a feature, you can do it. And in fact, the technique called PCA is just doing that, right? What PCA does is you can provide, okay, so have you all gone through the PCA as a concept in your course yet? Okay, what are the different ways in okay, Birender says not yet. Okay, That's fine, Birender. You will learn it. Rachit, don't worry about it. You'll definitely learn it. Okay. So typically, what it does is you will say that I want you to. The typical input for a PCA algorithm is you provide the data set with say 100 columns. You can say that I wanted 5 columns to be returned, but representing the whole data set, right? So now what it does is it does some permutations and combinations of data. It does some singular value decomposition and stuff, and it represents the whole data only using 5 columns and returns you that. So you can fit it in your memory, right? The other way of telling a PCA is you can say that I want 95% of variance to be retained in the data. Now you cannot define the number of columns. It will how many ever columns are possible to actually represent the variance, represent the data with 95% variance. It will retain those many columns, right? So that's what typically you know PCA technique does. Okay, there is a subtle difference between feature selection and dimensionality reduction, right? Feature selection is about picking up features that are useful. It's not rows, sir. It's always columns. We're just talking about the features. We're not talking about records. We're talking about features, Rajesh. Um, so I was talking about feature selection and dimensionality reduction. Feature selection is about this feature is useful, so I'm going to include it in my model. This feature is useful, I'm going to include it in my model. This feature is not useful, so I'm going to throw out of my data set, which means I'm terminating a column. Whereas dimensionality reduction is not like that. Dimensionality reduction techniques, one of the technique is PCA, and there are other techniques. Autoencoder is one such technique. Tisney is one other technique. Tisney is typically used for visualization purposes. High dimensional data, you get it condensed into 2 dimensions and represent it on a chart. That's what Tisney does. TSNE. Autoencoders or deep learning models. Again, it's non-linear combinations of data. The output is condensed form. It's PCA with non-linearity in place. Don't worry about it. If you have not gone through deep learning course, you will learn it. These are all techniques for condensing your data. So there you're not throwing any columns, but you are actually reducing the number of columns, whereas the columns are synthetic data, right? Okay, guys, you guys have gone through PCA lab. Right on the chat window. Okay. Okay. So what is the output of PCA? Is it readable? Or is it comprehensible? Components, yes. Avinash, that's correct. But is it comprehensible? No, it is not, because it will be a series of numbers. You cannot interpret what it is. But in a way, it is representing all the columns, right? So it is like this. Understand it from a yeah, that's correct. That's correct. Eigenvectors, eigenvalues, all of that is the right answer. No, it is not interpretable because of the reason that it will represent all the columns in a consolidated way, and the numbers that it outputs is something which you can see, but you cannot interpret in terms of what each column was that contributed to that column. It's like this. I have represented my rectangular's length and breadth as area, but if I just give you that column called area and ask you to decipher what is the length and breadth, you will not be. Right? So that's the simplest way you can understand what a PCA does for all the people that have not gone through the PCA course. Okay. The same thing happens with autoencoders as well. Right? There are multiple types of autoencoders: variational autoencoders, simple autoencoders, plain vanilla autoencoders, etc. You learn them on your deep learning course. So either you apply certain number of feature selection techniques, or you apply PCA in order to fit your big data or huge data into your memory. The whole thing we are doing because of curse of dimensionality, which essentially means as I go about creating features, the number of columns increases in my data set. The number of rows will be the same, but the number of columns will be large. and I cannot fit them into my memory. When I cannot fit them into the memory, there is no way I can fit a modular. So that's the problem, right? How do I solve my problem? Either I throw out the columns that are not much useful for my model, in my data, or I represent the whole data set in a condensed fashion with less number of columns. Either of these solutions will put the data set onto my memory, right? So that's what typically happens. Now, unfortunately, there are multiple techniques to perform feature selection, right? There is univariate feature selection. Simply, you can say you can perform a chi-square test, or there's something called gain attribute evaluation filter, which you could use, or you could use symmetric attribute evaluation filter. All of them will see how correlated a feature is with the results. If it is correlated, highly correlated, it is going to retain. If it is not correlated, it is going to say it is not correlated. It's up to you to go ahead and remove that feature, right? Now there could be another problem. Say I have a credit card data set, and there are two columns where income is represented. One column is represented in USD, and another column is represented in INR. You think both of these columns should be retained? Boys and girls. Okay, why? Yeah, everybody's Birender, I am interested in your answer. Why do you think rate might vary? But we're not. But the rate remains static, right? So yeah, a rate remains static. Whatever is the external rate, that will be there, right? So, but what I'm trying to represent here is there is redundant column in there, and this redundant column should be removed from your data set, right? So this will help you uh, to uh, to get a better model. Why am I saying you will get a better model uh, when you remove redundant columns from your data? How is that going to impact? Why would you get a better model? Variance error would be less. And I think from a normal perspective, yeah, variance is a Rachit. That's like a deciphered answer. Yeah. So what happens if you have correlation? Yeah, why would it overfit anyway? Avinash. Okay, think about linear regression, for example. How does a linear regression equation look like? So I'll give you an equation, a simple equation: 3x plus 4y plus 3x plus 4y plus 5z, right? So if this is the equation, yeah, all of you have given me, right? What is x1 here? One feature number one. What is x2 here? Feature number two. And there is a constant at the end, that is which is okay. But the problem is all the features will have some weight. If you have redundant features, that redundant feature will also have some weight. So which means you will get a line that is not best fit, right? So by removing that feature, you are actually fitting a better line into your data set, right? Therefore, over representation of feature is required. Yeah, that's all I'm saying also, Avinash. But why is it not? Why you should not include such features is what I'm doing. So there, you don't have to manually identify this. There is something called core graph in both in R and Python. You can use that core graph in order to remove all those features that are highly correlated. It doesn't have to be the same kind of information as well. Say the earlier example I said USD and INR. You don't actually need to have same information that is represented across two columns. There could be a situation where two columns are highly correlated, right? So those columns also you can remove. An example could be the number of years since his education is complete, number of years of experience, right? So they are not same. Number of years since his last education is complete essentially is from the day he has completed his education until today, how many years have passed. Okay, in most cases, Gundappa, that's correct. Multicollinearity is what we are talking about, right? So that is one thing that you will have to test. So I'm giving an example for it. So Piyush has finished his education in 2013, for example. So 2013 to 2019, it's about 6 years. But 2 years, he was just searching for job after his education, right? So, but if you look at both the columns, most people nowadays get selected in campus. That essentially means the number of years passed since his last education and experience is going to be the same. So if you actually do a correlation between these two columns, it's almost going to be very high. So there is no point in having both these columns in your data set. You may have to remove it. How do you identify that? Again, through testing the multicollinearity. There are commands for it. Go ahead, search Google. Google is your friend. Stack Overflow, copy paste the code and do it. All right. So yeah, this is all again whatever I have spoken about: informative features, discriminative features, non-discriminative features, etc. This PowerPoint will be shared with you after this talk. You can have a look at them. So feature construction. Are we also talking about auto correlation? Can you expand auto correlation, Rachit? I am not sure about the concept. Oh, that's too technical for me. I don't even know what the test is. I have to be honest with you. I'm really sorry. Yeah, you're taking my Viva exam. Really sorry, Rachit. Yeah. So I have not used that. And another thing that you will. Yes, that's correct. So when I knowing the correlation between target and features, that is what you do when you do chi-square attribute evaluation filter or gain attribute evaluation filter. These are different ways of measuring how a feature is going to impact your what do you call impact your target. Right? We've already spoken about that. Yes, Rachit, you should get in touch with Gundappa. Looks like he has some knowledge on autocorrelation, so he can definitely help on that. I'll also brush up my knowledge on that once I go back home. All right, so dimensionality reduction, we've already spoken about PCA, highly correlated PCA and autoencoder and all of it. Feature extraction, so this is one other feature transformation technique. Say if there are two dates that are there, instead of representing two dates as two columns in your data set, what you can do is subtract one date from another one. So another example that I gave you is years. What is the current date? If I have current date as one column, and if I have last education date, instead of representing it as two columns, what I can do is I can subtract last education date from the current date, and I can represent it as one column. So that is feature extraction. And there is absolutely no limit to what kind of features you can create. You can create a number of features. You can draw trend lines, and you can source data from outside external world, something like stock prices and market demand for a particular technology. All of this will impact your data. Based on the all of this will impact your problem based on the current problem that you're trying to solve. Say for example, if you're trying to look at how much money a person will earn, then there are several things that you can source from outside world, like the number of job openings that are there in the current week, last week for that particular technology. and is it in the number of job openings on Naukri for that particular technology, is it increasing or decreasing? How many people are available in that particular technology? Is he certified from a reputed institute? How is the how is the graph for that particular institution trending? Is it upwards or downwards? How is the sentiment about that institution? What is the reputation of the previous organization he has worked? That data you can source from Glassdoor. How many people have given recommendations for that particular individual on LinkedIn? This is some data that you can source from LinkedIn. So this is where your domain expertise comes into picture, and it's unfortunately it is not a science; it's more of an art. You need to sit down and think about all those possibilities, and then you need to correlate them. And most of the times when you're fresh in an organization, you might not have very deep knowledge into it. Over a period of time you will develop it, but until then you might have to be friends with the so-called domain experts or business analysts so as to reap their knowledge and make the best features possible. Right, now the data is done. Now what? Data modeling. We've already spoken about the data modeling problems that you would yeah. So how these are things that I mean there are problems that are there in data modeling. So we will have to go ahead and solve them. How do we solve them? So I will take you directly to the part that I wanted to show, the solutioning part. I promised you to show the solutioning part at 12, and I'm delayed by 10 minutes. I'm sorry for that, but here you go. There is a concept called AutoML. So I've talked to you about imputation techniques. I've talked to you about feature selection, dimensionality reduction, selecting the best algorithm, uh, selecting the best ensemble, and all of it. Right? Ditch all of that. Right? You don't have to do any of that. People have come up with smarter ways of doing things. For example, they've come up with something called AutoML, right? Where you just feed the data and it does everything for you. All that you need to say is give it some time, right? Say that go ahead and do your experimentation for the next 2 hours and uh, get me the output, right? And in real world, this is what I do in my world. So I don't actually go ahead and create models individually. I'm going to show you um, an example that I've created for the purpose of this session. I've taken the iris data set. I'm not sure if you've gone through any AutoML libraries earlier. There are lots and lots of libraries. The most popular library is something called as Teapot. And because you're all familiar with sklearn, which is scikit-learn, sklearn also has a library called AutoScaler, and that's what we're talking about. And that's what we're going to be using here. So this is a typical credit card loan status data set that I've taken. All of you see my code? Yeah, very good. Thank you, Rachit. So if you look at it, I have read the data set and I have done some pre-processing around dropping the not null records and all of it. Those pre-processing I have done, and I have checked how many records are there. What is the shape of it? Are there any null values after pre-processing? Drop NA removes all the records. I was just quickly doing this notebook yesterday, so I dropped instead of doing any imputation. And after that, whatever unfortunately, I see certain columns have been read as object. Object is a internal representation for Python, and which is not recognized by my model. Therefore, I have converted them to categorical with this particular code. And I'm again looking at the data set here, right? And this is the interesting part. And this part you would know, right? So what is it doing? It is dividing my test data and training data set into 90-10 portions. It is keeping aside the test data, and after that I'm converting the values into a numpy array. This is how my y test looks like, and this is how my x test array looks like after converting it into a numpy array. And all that I will have to do after all of this is just this command. I'm just importing the libraries, which is auto sklearn, model selection library, and stuff. And this is it. This is it I'll have to do. In real world industry situation, this is what I do, and I go play my poker game or whatever game. What I'm telling here is I'm passing the data set, and I'm also I'm actually instantiating that object, and I'm saying that run my task for 120 seconds, and in every run experiment with multiple models and multiple techniques, and spend about 30 seconds time on each of the model and get me the output. And how do I evaluate which model is better? I'm saying that use a five-fold cross validation strategy. Right after the run is done, go ahead and terminate the folder. That's all I'm saying. Right, if you look at here, I've got the AutoML results. Does AutoML need any high performance machine? Birender has asked me this question. No, it doesn't need any high performance machine. What it needs is a normal machine. I just had a simple 4-core machine, and I was still able to run it. And multi-core processing is possible. It's just that you can decide how much time is required to find out the optimum model. And that is a heuristic. Nobody can tell you how much time you can let AutoML do the things. So in this particular case, I've just let it do the things for 120 seconds. Right? But I can, did you arrive at cross? Priya, I'm not sure about your question. Can you rephrase the question, please? Okay, sure. So I just left it for 120 seconds, and I wanted to do a quick run, and I did that. And what it actually does is it gives me multiple experiment results. I'll show you one experiment that it has done. What it does is it's a class imbalance data set, so it weighted the data set. Oh yeah, you can do 10-fold cross validation. It's k-fold, right? What you select for k is up to you. I wanted to do evaluation using k-fold, I mean 5-fold, right? And then I talked about one-hot encoding, right? This without me having to do the transformation, this has already done it, and it has chosen a classifier called extra trees classifier, and wherever it has to do imputation, it has done imputation using median. Right, in earlier case you will have to individually do mode, median, mean, and stuff, and have to test it. Here it has done it, and it has not done bootstrapping. It has not done any ensembles. I also have an option to pass ensemble as an option here. Here I said ensemble size equal to 1. I can say ensemble equal to 50. That essentially means that it is going to combine 50 different algorithms and try to see what will be the 10-fold cross validation for it. I mean, or 5-fold cross validation result for it. And whichever mod, it is going to experiment internally with almost 14 different algorithms that are there inside sklearn, and then it is going to fetch you the right kind of algorithm. When I say automl.show model, it is going to show me the best model out of all the models that it has experimented in the last 120 seconds. You are absolutely not touching anything. All you're not doing any Ankit Kapoor. Okay, sure. All right, AutoML is a library. AutoSQL, can we use this in a Kaggle problem? Yes, I have used this for a lot of hackathons. I am a winner of multiple hackathons, and this is one of the techniques I follow in hackathon as well. As soon as I go in, I take the raw data set and dump it into an AutoSQL kind of algorithm, and it is going to automatically try various models, and it is going to get you the best model. And if I were creating new features, what I will try is to see if I can beat the benchmark that AutoML algorithm has given. Right? If AutoML has given me, yes, it will take care of categorical variables. If you see in the example that I have just explained, you see that there is one hot encoding. In some cases, it was doing no encoding when the algorithm doesn't demand it, but you will see that it is also doing one hot encoding. It is automatically taking care of that, Gaurav. You don't have to do anything. So you're not doing feed. Can you please share this code? Yes, we are sharing it, Rachit. Sure. Ankit, you have asked me to repeat the thing once again. I am doing it for you. Right. So AutoScaLearn has both classifier as well as regressor. Depending on the problem, whether you are solving a regression problem or a classification problem, you need to use that particular AutoScaLearn API. What I'm doing here is I'm telling AutoScaLearn function to run experiments, several different experiments for 120 seconds, right? It will try the combination. It will try the combination of hyperparameters, combination of models, combination of feature imputation, feature selection, and all of those techniques. It will try to do in this 120 seconds. It will perform multiple experiments, right? But there is a situation where an experiment cannot be completed, right? It might take a longer time. Say, for example, XGBoost or ADA boost for 100 iterations. That itself will take 120 minutes or 120 seconds. So which means you will be experimenting only with one model, right? So I want to restrict the time each experiment also takes. And that's what I'm defining here, saying that runtime per limit, per runtime limit, which means if my experiment exceeds more than 30 seconds, terminate that experiment and initiate a new experiment in that place. So that means in 120 seconds, it is going to try as many experiments as possible, but each experiment is going to be tried only for 30 seconds, right? And I'm also saying this is my temp folder and output folder that you can use. It has no good value. Basically, you're defining this is where you store your temp files. And then output folder is important because this is where the code for the final model is. Yeah, I'll come to your question, Yogesh. This is where the final model code is located. You can look up that code. You can copy paste the code into your Python file that you're going to give for production. Ensemble size is a very important element in this particular case because I've run the experiment only for 120 seconds. I've restricted it to ensemble size 1, which means it is not going to perform any ensembles. Just one algorithm will be taken each time to build the models. But if I performed ensemble equal to, if I've given the input as ensemble equal to 2 or more, it is going to combine the algorithms and build the models, right? And then so in a non-AutoML situation, all of this I'll have to take care. I'll have to sit down and perform all those things. But in an industry situation, this is what happens. We don't do it, right? We will have the machine do it, right? And then by default, I can also define that the evaluation of a model should be performed using tenfold cross validation. You can also define that it can be run in a multi-core mode. That's the reason I have imported multi-processing and all. Look up this API. It's very interesting. There are lots of parameters, other parameters available as well. There is a clean sklearn, AutoScaLearn documentation also available. So please look it up for other options. So once I do it, it is going to experiment with all of them. And then when I say AutoML.show, all that it is going to show me is the best model that came out, right? One of the things that you need to remember is it is not going to store the model until you say AutoML.fit. Right at the end of all the experimentation, it has done several experiments and then deleted it immediately. Yes, it also does neural methods, but it does only multi-layer perceptron. That's about it. Yeah, it will do only supervised model. Like I said, there are only two kinds of model APIs available, one for classification and one for regression. That itself means that it is a supervised model. It's only available for supervised. Yes, sir. Scaling is also done. Yes. other other hyperparameters other than what you have showed. These are not hyperparameters, these are parameters. Hyperparameters are individual to an algorithm that is also experimented with it, right? Your AutoML will take care of it. And there is a very similar library called Teapot, right? That is also genetic algorithm. That is a genetic algorithm based algorithm, and you can look that up. What do you mean by storing the model? The final model. So why am I building the model? To reuse it for future scoring, right? So I need to have the final code. I don't want to rebuild it again, right? I want AutoML to give me that script that I can directly put it in the pipeline. Hyperparameter for stratified sampling. Yes, when you say CV equals to find, it is going to do stratified sampling. Right, Ankit, thank you for confirming that I answered your question. Right, so this is one technique that we're going to do. All that you're going to do is when you say show model, this AutoML will show you what is that pipeline that it has taken in order to build the entire model. I'll just give it a couple of minutes. Just have a look at it. Right, the best model here was something called as I mean, it has performed one hot encoding. It has also done. Somebody was asking about scaling, right? It has standardized the data. Saurabh Kirar, you have asked me about scaling. Here it is. Yogesh, what do you mean by data cleaning? You mean removing all the bad characters and stuff? Yeah, it does imputation. If you see, there is a place where it talks about imputation strategy. Did that answer your question, Yogesh? Yeah, cool. It does everything. All that you'll have to do manually, it is all done. Right? The more amount of time that when I've spoken for 2 hours and I solve your problem in like 10 minutes, and this is what I do. All data scientists, most of them are primarily lazy. They come up with smart techniques to solve their problems. And during the initial time of the session, somebody actually told me that they've used Teapot. Yeah, Teapot is a great library. Yes, sir. Yes, it uses same strategy, and that's why they're highly paid. Yes, yes, Yogesh. Yeah. Yeah, Teapot is a great library. I'm not going to be talking about it here in this session, but when you get time, have a look at that as well. Okay, but it's very, very similar. Nothing great about it. One of the Birender, you said, but it is not good. Could you explain? Is the code not good? Amit, I'll come to your question. Birender, could you explain your question, please? Yeah, so imputation strategy for categorical variables. In this case, you see that it has performed one hot encoding, right? Already. So there are no more categorical variables. It's already transformed it into numeric variables. Yes, it applies same strategy for all features, but internally, if you see the pipelines that it has experimented with, it has actually done mode, mean, and other techniques for all the features together, and it has created different data sets, but tried with the same algorithm. And wherever it got the best one, it has showed it as output. Ravi, that's a nice question. What you will focus on when everything is being done by machine is you should know that there exists something called AutoML, right? So far you didn't know that. I just let you know the secret recipe. Right, I'll talk about productionization in a short time. Right. Yes, in the 120 minutes where it has run the Yeah, I'm not sure who said it is not used regularly, Avinash. If it's a naive data scientist, he will go about creating each models, and because there is a manual dependency, things are slower. But a lot more people are using it these days. You should look up something called as neural architecture search from Google. Google has come up with this particular phenomena. It's called. Yes, yes, I'll come to you, Shailender. Neural architecture search is a phenomena where a neural network is built by another neural network. So just have a look at it. This is being accepted as a popular mechanism in almost all the large companies as well. So I'm not sure why other data scientists are not using it. Maybe they don't know, or maybe they don't see a value, or maybe they want to prolong their project for the next few months. Right? That's all I could answer. And what are the cons of AutoML? AutoSKLearn can only experiment with the algorithms that are part of sklearn. There are only 14, 15 algorithms. But if you look at it, there are tons and tons of algorithms out there. Right? So it can only do permutations and combinations of the techniques that are supported by sklearn. Same with Dpot. Same with AutoVeca. Right? And you have to decide how much time it has to run the experiments for. Here I have set it for 120 seconds. Right? You could say it can run for 24 hours, but what is the guarantee that it will find out the global optimum solution? Right? It can still uh, no, sir. Just look for neural architecture search by Google. You will find out. It has nothing to do with reinforcement learning. There is a pretty, plain vanilla neural architecture search as well. How does auto learn and other ones define? You mean auto sklearn and AutoVeca and Teapot? How do they differ between each other? Okay, Yogesh, each one of them are open source libraries from different people. That's all it is, and the underlying principle slightly differs. Say, for example, for hyperparameter selection, Teapot uses something called as genetic algorithm, which is a more intelligent way of searching the search space, whereas AutoSKLearn is going to look at the data set itself. The candidate models and hyperparameters it picks up is based on what previous algorithms it has, what previous data set it has seen. So if I'm doing a credit card data set, it already knows there is a credit card data set that it worked on previously, and it picks up similar kind of models and tries on this data set. Right. So underlying philosophies are different, but the same thing is accomplished by different libraries. Is there a chance to no, Sudhakar, no, it doesn't. So it does not repeat the experiment with the same algorithm all the time. Teapot as understood. Ankit, I'm sorry, I did not prepare this session for Teapot. I was told specifically that you guys are you guys have learned sklearn only in the coursework. So I was asked to do the experiment on using AutoSKLearn and not Teapot. What strategy you follow in hackathons? Yeah, yeah, Gundappa, that's a good link. Yeah, you could go here. Um, what strategy you follow in hackathons? Is this? Yeah, why not? Kaggle or Analytics Vidya, they do not ask you for solution. They actually ask you for the final, what do you call, the performance measurement. Right? They are looking for, no, it's not Teapot. It's not TEA. It's TPO. It's Teapot, as in Gundappa has pasted the link. Look at it. Yeah, that's right. Can you give some references for Teapot? Gundappa has given it. After the session, maybe I can email Piyush to distribute the links for you. And in fact, like Kaggle and Analytics Vidya, there are a lot of competitions where you will only have to use auto ML techniques and come up with the best answer. Search for auto ML competitions on Google. I'll give it 15 seconds for you. Avinash, you're not able to see others' comments. Is everybody else? Oh, okay. Maybe. Okay, don't worry about it, guys. We're going to send you the teapot links later. Okay, I'm sorry. I didn't know that you guys can't see each other's comments, right? All right. So this is AutoML, right? So without doing anything, with 10 minutes of code, I was able to achieve a 77% accuracy in predicting if somebody gets a loan or not. I just finished it, right? And in a hackathon, typically I dump the data and yeah, Avinash, I understand. We're pasting the comment for you. Yes, I'll come to that, Gaurav. If everything is done by AutoML, what is my job, right? Your job is to create those features. Your job is to do feature engineering. When I say feature engineering, collecting the right kind of data and thinking about what kind of columns will rightly contribute to the model's better predictions, right? And one of the things, if you actually look at it, it is only doing permutations and combinations of the techniques that are available within the sklearn library. That's about it. But it is not doing log transformation, or it is not actually creating new features from the existing data. It is not extracting the features. Say, yes, it assigns weights to, I mean, that's what a machine learning model does, right? I mean, if you're building a logistic regression model or a linear regression model, it assigns different weights. And in fact, when you build an ensemble, it actually gets you different weights for different models that are contributing to the ensemble as well. We have to look at yeah, you can define what I mean. You're right, Gundappa. I mean, if it's a class imbalance data set, accuracy may not be the right metric to look at. You can actually give precision recall and F score as well. In general, auto sklearn sufficient for industry problems? Yes. At the end of the day, it builds a good model. It is searching the universal search space for you. It's good enough. And in fact, when you go to your senior management saying that this is the best model that I have fit, nobody is going to ask you how have you come up or how have you arrived at this particular model. In fact, you have an evidence to show that, okay, these are the models that I have fit so far, and out of all the models, this is the best model that has given me the best performance measurement. You have the evidence to show. So whether it is done by a machine or whether you have manually sat down and written the code to do everything is immaterial for them. I don't know why would somebody torture you to write the code manually when automatic things are available. Okay, so I was talking about hackathon. So in a hackathon, typically what I do is as soon as the data set comes through, I do the general checking of all the data set that is given to me, and I dump the data into one of the AutoML libraries, and I get a particular score. And my goal for the next 24 hours or half a day is going to be creating features that will pump into another AutoML script, which will increase my accuracy. I repeatedly do that. So I don't spend a lot of time writing the model code. Rather, I try spending my time on thinking about what data I can supplement, which will give me better accuracy. The better the data, the better predictive features, the better model you have, the better predictions you have. Is that convincing, guys? And that's how I won hackathons a couple of them. All right. Thank you. Thank you so much. All right. One other problem you would encounter. I built a very super good model with the ensemble. Now what will I do? How I have to productionize it. Let us see. Creating features is something. Creating features is an art, not a science. No tips for that. It is completely dependent on the problem, and that's where your business knowledge comes in. Okay. So what is Yeah, just give me a second. I'm going to grab some water. Okay, so the reason I had to give you the theoretical foundation was my intention was to link everything that you have learned in the course and give you a quick recap, and then only I want to show an AutoML thing at the end. If I would have showed AutoML right in the first place, it wouldn't have made sense to you because you would have thought it's just a piece of code. But now, because we went through almost 1.5 hours of theory, you understood how hard it is to do data science manually and how easy it is to do when automated things are available. So I hope that theory that was covered for 1.5 hours was useful for you guys. Uh, okay, nobody answered, so I think it's a yes. All right, thank you, Gundappa. Tushar, you may have to log out and log back in. Yeah, thank you, Gundappa. You saved my day. All right. So once I build the model, the next challenge comes up. How do I productionize it? So there are so like I gave you the movie thing. So you watched a movie for almost 3 hours, and after watching the movie, you are now expected to answer a question that I'm going to ask. So when I ask you a question, you are not allowed to watch the movie once again for 3 hours, right? So that's how model also works, right? You took so much time to build a model, and now you have to answer the questions that I ask you, right? So once you build the model, you have to deploy it somewhere. What it essentially means is you take the AutoML script, the AutoML script that is stored here. Okay, I can't show you the script because I did the experiment on a Linux machine and we couldn't use GoToMeeting on a Linux machine. So we had to copy the script onto a Windows box that I'm doing the GoToMeeting from. So I don't have that file, but typically it is stored in the output folder. You can actually take that script uh, and actually execute it, right? But to save the model, how can we make this thing understandable to the management? We can tell them about AutoML and all what is. But Shailendra, why do you have to tell them? Why do you have to let your secrets out? As long as you say that, okay, this is the best model, why do you have to tell them you have done it through AutoML? Does it matter? Okay, no answer. At least there should be something tangible. Yeah, you will have something tangible. Are you sharing this code with you guys? Yes, I am sharing the code with you, Sudhakar. Okay, so because we have very less time left over, I quickly wanted to tell you about productionizing the model. So typically, whether you build a model using manual steps or you build uh, the model using AutoML, the idea is to persist the final model, right? What essentially it means is if you open a Word file, you write something in the Word file. Unless you save it, it doesn't save as a file, right? So similarly, when you build a model, you have to persist the final model onto your disk as an object, like you save your Word file, right? So the process of saving your model onto your disk is called the pickling. The process is called pickling, and you can relate it with your pickles at home, right? You basically have pickles at home, and whenever you want, you will reuse it. So basically, I have built a model. I will pickle it, and whenever I wanted to reuse that particular model, I'll just load it and score whatever is the incoming record, right? So I want to quickly go through the pickling process. Again, to do pickling, we were if we don't tell them, what if they come and ask? Uh, Avinash, I will touch base with you after 1 o'clock about this. We have a 30-minute QA session. I didn't understand your question, but we can elaborate on it. Uh, Gaurav, are you saying you already knew about or pickling? Okay, sure. How many of you don't want to do pickles in this course or in this session? Shailendra says, yeah, unfortunately, a lot of people are saying that they don't know pickle. So, yeah, a lot of people are saying they don't know pickling. So they want me to do it. I'm really sorry, Gaurav. You have to excuse me for that. We're going to cover that. Right, right. Okay, so the idea is once you build the model either using manual process or through AutoML, the idea is to save that particular final model that gave you the best performance onto the disk. And whenever you want, you can just load that particular model, and then you can go ahead and score any incoming new records, right? So typically when you're doing the course, this is not what you do, right? You have a file where you have training data set, test data set, split at a point in your notebook. You rerun the entire notebook. Therefore, your model is stored in your memory, and then it actually gets the test records get scored. But in industry situation, that is not what happens, right? You do the project for 3 months. At the end of the project, you save that model, give it to productionization team, and forget about that model. They will productionize it, and any new incoming records will be stored. It is not that every time they want to score something, they'll rerun the entire notebook. It doesn't happen like that. So think of the process as saving your Word file onto your disk, right? And once you have saved it, you can anytime open it and then you can read it in a Word file. But similarly, whenever you pickle a model, you can go ahead and reload it onto your memory whenever it is required, and the model will be loaded onto your memory. This model can be used to score any new incoming records that are coming from other databases at any point in time, right? So that is what it is. So here, all of you know Iris dataset, right? Iris is a flower and it's a toy dataset that you can play with. And I've used a toy dataset here. The dataset is already available on Iris, on AutoScaLearn. Sorry, sklearn database. I have loaded the dataset into Iris here. I have split them into training and test data. Gundappa voice is not coming. Is everybody okay? Other people are able to hear? Okay, sure. Right. So I've just loaded the Iris dataset here. I've split the dataset into test and train, and I have trained using a random forest classifier. This is just an example. I have not used any pre-processing, or I have not used any of the sophisticated techniques here. I just trained using random forest 500 trees. And once I do it, all that I need to do is I need to pickle it. There is a library called pickle. You may not have it in default Anaconda installation. You may have to do conda install pickle if you don't have it, right? And all that I'm doing is I'm just naming it as final model, and this is the command to save the model onto your disk. The moment you do it, pickle.dump, rf is the model that I've created. I just say that, and I'm saying that save it with the file name called finalized model.save, and write it as a binary file in write mode. This is like file open and file writing, right? So that's all I've done. The moment you execute this particular command called pickle.dump, it is saved onto your disk as this name called finalized model.save. And now your final model is there forever on your disk, right? Whenever you want it back in a new Jupyter notebook also, all that you need to do is import.os, os.change directory, put it to that directory wherever this file was located, say loaded, pickle.load, and then give that file name that is there, finalized model.save, read binary mode, and that's it. And if you have to score it using that name, model.score, whatever is the test data set, just pass it, and I'm just comparing it. It gave me a 96% accuracy there, right? So pickle is not the only library. There are other libraries as well. Another library that can do the same thing is joblib, right? I provided that example. It is absolutely no different. It is the same. Instead of saying pickle.dump, you are going to say joblib.dump, and you're going to load it in the same way as you did pickle. But the only difference that you'll have to remember is pickle is not very efficient at storing data, right? In what scenarios you would have to store data when it comes to um, in what scenarios you would have to store the data in model building? Why would you have to store data? Guys, any thoughts? For comparison, yes, Sarabjit, very nice. Yeah, Sarabjit says, in a k nearest neighbors kind of situation, it is required that you store the data. If you remember from your class, they would have taught to you saying that k nearest neighbor or k means are lazy learners. The reason they say that it is lazy learner is because yeah, lazy learning algorithms. That's right, Rachit. The reason they say it is lazy is because there is no real model. So on the fly, it basically classifies things based on the distances computed. So it's actually the data that needs to be stored. It is at the execution time, it maps the distances and it classifies or clusters. So you need to store the numpy elements there. So pickle is not very efficient at storing numpy elements. So you may have to do joblib. Okay, joblib is good at that. So that is the only difference between joblib and pickle. But it's that easy, right? Productionization of the model, you just do a pickle file and give it to your production team. They're going to ensure that there is pipeline. Joblib stores data as well. Yes, pickle also can store it, but it is not efficient at it. Okay. Sudhakar, did I answer your question? Okay, cool. Right, so you can adopt both of these mechanisms, either joblib or pickle, and go about it. But think about it. This is good enough for scoring it overnight. If you are running in a batch mode, that is good. But what if I have a credit card application? Uh, is there any efficiency issue between pickle and joblib? Yes, there is. If you have saved, I mean, I know of one problem where if you have saved a model with Python 3.x using pickle, you cannot open that file using 2.7. You cannot load it on a 2.7 machine, right? But joblib, I think you can do it. Okay. Gundappa, that is one thing that I see as difference. I mean, there is a recent phenomena where people are not even going for pickle and joblib. They're going for storing all the models as JSON. That is also possible. You can look for a command called JSONify. I've not extensively seen that is being used in industry. We were always asked to do pickle or joblib, but nowadays people are looking at storing file as storing the models as JSONs also. So one of the advantage with JSON is irrespective of whether you use irrespective of using Python 3.x or 2.7, you can load it anywhere. Absolutely anywhere. It's independent of the version of Python. Okay. Does joblib.dump would store the data as well? Yes, it can store both data as well as model. It's the same way, right? I'm due to I'll take the questions in a short period of time, but I quickly want to cover one other important topic. We are just left with 10 more minutes. If we can park the questions, I'll come back to you after 1 o'clock for questions. Yeah, I've been getting a lot of questions, but please bear with me. So, so think about it. This is good enough if you wanted to if you wanted to score your data in a batch mode, that means every night my my pickle file gets loaded onto the memory. There is data coming from another system, and I score the data and I send it back to the database. Good enough. That is batch mode. But what if you have an online application, right? Think of it like a credit card application, bankbazaar.com, right? What do you do there? You go ahead and fill in your details, and immediately it is supposed to go back, look at your details, and come back with the relevant credit cards based on your income level, experience level, and the lifestyle, right? So it is not an application that can wait until the batch runs in the night, right? It is an online system. How do we do that, right? So we will have to rely on a client server kind of system. So there is something called Flask. Flask is a GUI. You can create REST APIs. I don't want to get into SOAP and REST at this point, but you can go and look at REST API is a kind of API. You can create you can actually expose your model that is pickled as an API. So which means you can send a post request and you can get a response. So you host your API to respond on a particular port, and then whenever you query it from a client, so you can get your model run, and then you can get a response immediately back and display it on your UI system. And you typically use things like Django or Flask, which are all Python applications again, to create APIs. And this is again Iris. I've used the same Iris finalized model here. I'm loading it up till here. There is no difference. The only difference here is we are doing from Flask, import Flask, request, and JSONify. These are the libraries that you will need to install. Yes, Gundappa, that's right. We can use Flask, Django, Pyramid, and there is Py3 or something like that. There are lots and lots of uh, lots and lots of options, right? So this is a decorator basically to say that it needs to wait for post requests. So the moment you have this decorator, it is going to open up itself and accept any new requests that are coming up. AWS SageMaker, that is a proprietary tool by Amazon. I'm not talking about proprietary tools. There are lots and lots of them. Azure also has their own. Google Cloud has their own. I'm not talking about the proprietary tools. I'm talking about open source things that are available, Gundappa. So Flask, Django, all of them are open source that are native to Python. So what I'm saying is listen on port 8111, and if there is a request, if there is a post request coming up, then use that particular post request, take the data from there, score it, and respond back. That's what I'm doing here. And here in the predict, what I'm saying is take the JSON request, take the data that is coming on the port number 8111, and then there is sepal length, sepal width, petal length, and petal width that is passed. Take all of them, convert them into a NumPy array, and then I'm just printing the predict request, and then I'm saying that there is a model that was loaded. You see the pickle.load here. The model is now loaded to memory, and it is called with the name model. Model.predict, you already know what it does. The record that needs to be scored is in predict underscore request. It is there. It comes up with the prediction, and then I'm just printing the prediction here just to do debugging. And output is there in prediction in the first. It's an array that is there in the first cell. It is there, and I'm actually passing back the JSON of the prediction. So I'm returning the prediction to wherever this function was called. Right? That's all is the server module. If you don't understand it, don't care about it. The code is exactly the same. Right? Just copy paste the code. If you don't understand JSON, if you don't understand API, nothing to worry about it. This is exactly the code. Right? You may have to change just the port number and the model that is loaded and the record that it is going to take. Right? And how do I call the server? It's here. Just the statement. right? Import requests, this is an essential library, and then I have exposed that API on what do you call port number 8111, and JSON.dumps is what is I'm storing my sepal length, sepal width, petal length, and petal width as a JSON, sepal length as a JSON, and I'm saying request.post. I'm saying pass the URL and data as parameters to that particular command. And when I do this, it actually calls the server. It scores the record in the server itself and returns whatever is the JSON that is stored in an R, and I'm just printing R in this particular record. Right? How do I run this? Very simple. Go to command, type Python space. I'm going to type it for you. Python space server.py. That will start running the server code. And similarly, Python space client.py. That will run the client code. That's about it. So this is how you can embed any model in any application, right? And if you wanted to do similar thing in a client server application and not a web application, then you have another thing called Qt, as in yeah, I'll type it for you. It's not CUTY, it's Qt. Yeah, for some reason my messages are not coming to you. No, it's just Qt. So similar to Flask and Django, you have Qt. You can use Qt in order to design your client server kind of. Yes, that's right, Gundappa, Qt. Okay. Yeah, so it just said the record that I have passed to the server, it is a Versinica, which is now represented with 2. I got a result right away and I have printed it. Okay. So this is how generally you predict when you particularly score your models. Okay. I know it's a lot of things that we have talked in the last 3 hours. Really appreciate all of your patience. We started with 59 members. It's amazing to see the count is 49. So only 10 people dropped. That's a very positive sign. Thank you everyone for attending. It's now 1 o'clock. There is one other thing I wanted to close this session with. There is something called interpreting machine learning models. So just because you have created XGBoost Dart model with 500 trees, nobody is going to accept. Yeah, I'll come to the questions in some time, Amit. Just bear with me. Nobody is going to accept it as is. Everybody is going to question you. Everybody is going to ask you, why should I trust your model, right? There, I will ask Great Learning to arrange a separate session for you for interpreting complex machine learning models, right? It's not, say for example, if it's a linear model like an SUM or linear regression, you see the weights there, you see an equation there. It's easy to explain saying this is the feature that is contributing more. Because of this feature, it is getting predicted like this. It's easy to say that. But when it comes to uh, explaining a random forest or uh, explaining an XGBoost or explaining a neural network, we flumble. And the moment we flumble, stakeholders will not accept your model to go into production. That's a topic on its own. And there are tools for it called Line, Skater, Daleks. I would really take another hour to do that session. I wanted to cover in this session, but I know it will be really overwhelming, and we've already passed the time that's allocated for this session. Yes, auto feature engineering, Gaurav, that in itself is a topic. You can create mathematical features. Look at this library called Feature Tools. Wonderful library. It creates n number of features. That is one of the techniques that I follow in my hackathons. How do I easily create features? I use feature tools. Priya, feature tools. Feature tools. There is an amazing analytics Vidya blog. Just read up. For some reason, our messages are not coming to everybody. I'm not sure. We just typed feature tools and a whole lot of other messages. I'm not sure if they're coming to you guys. Okay, that's all I have to say today. You've been wonderful audience. I really loved talking to you, and over the process, I also consolidated my knowledge, and I hope I was able to do justice in the last 3 hours. But I'm really open for questions. So next 30 minutes is yours. The way I do is I will read out the question and the name of the person, and then answer the question. Yes, we're going to share all the PPT video, everything to you. Sure. Amit, I will take your question. I have one doubt. In supervised learning, we have label data, and those labels will be available on future data also. No, it is not. On future data, those labels are not available. See, the idea is you build a model for, say, you are a bank, okay, for example, and if you are a bank and you build a model to predict if a person is a good if you extend the loan, if a person is going to pay back or not, is the question or the problem you're trying to solve. So you're asked to build a model by your bank, and what do? You build that model. And what is the purpose of the model? The purpose of the model is, in future, if there is a new applicant for the loan, you should be able to detect if it's going to be a good customer or a bad customer. Otherwise, what is the point? There is no label for it. Okay, did I answer your question, Amit? Yep, cool, very good. I'm open to taking more questions. In real time, we may not be using Jupyter. Yes, what I do is once my Jupyter, yeah, so this is for Sudhakar. Sudhakar asked this question. In real time, we may not be using just Jupyter to develop our code, as it would be a machine learning at scale, a real-time prediction. What would be the architecture? No, simply what I do is I copy paste the code into notebook, a notepad, and save that file as server.py or client.py. And I execute that like I just pinged you, Python space what do you call server.py, and that's it. So Jupyter Notebook is development environment; it's not for production. Uh, how Naga Pavan Kalepu asked me, how can we use? Yeah, so as long as there is an means basically he's asking how can we use these models in other programming languages. Yeah, of course, man. As long as it is hosted as an API, you can call from any language. It's just an HTTP post call, right? So it's as simple as that. Pawan, did I answer your question? Yep, cool. Can we apply different imputation techniques? Yogesh, unfortunately, that is not. Yogesh asked me a question: can we apply different imputation techniques on different feature columns? Yes, you can when you build the model in a manual fashion. But if you're doing it in AutoML, no, it is not possible. It applies one imputation techniques across all the columns. That can be termed as one of the demerits of AutoML. Okay. When we talk about production, how do we perform unit test or integration test for ML? Yeah, so Piyush asked me this question. Unfortunately, there are no rigid processes to productionalize the models. There are no standards for performing unit tests or integration tests. So what happens is the moment you productionalize the model, it becomes a piece of software. It's no more data science area. So whatever practices you have in standard software engineering, you adopt here also. Because it becomes part of the web application, or it becomes part of the batch process that you're doing, right? So it's going to be the same. I am analyzing the. Piyush, did I answer your question, or any more clarification needed on that? Okay, I guess Piyush is left already. Shailendra asked me. Yeah, yeah. Model verification. Can you expand on what is model verification, Piyush? Okay, while I wait for Piyush, I am Shailendra Singh asked me a question. I am analyzing the data. Can I prepare dashboard using Python like Tableau or other tools? Yes, of course you can. You have the dump of data. All the details are there. You could, and in fact there are libraries available. I don't remember the name of the library, but you could call Tableau API within Python also. That's absolutely possible. Uh, One second. Uh, so Naga Pavan asked me a question: How to remove human bias? Bias? Any techniques? Okay, human biases are human biases. There is nothing you can do about it. Unfortunately, machine learning and AI intelligence has not surpassed human intelligence. So you have to live with it. No automated tools. You change the humans. Yes, Nihar. Um, Pawan, you may have to talk to Nihar about it. Nihar sent me a message: change the human. Birendra, yes, I'm reading your question. Um, Yogesh, I'll come to your question. I'm now on Birendra's question now. How do we handle new data in production? Do we need to follow same? Yes, that's a wonderful question. Birendra asked me a question. How do we handle new data in production? Do we need to follow same cleaning and data pre-processing techniques as we did for training? Yes, you have to, right? Otherwise, even see whatever. Okay, your model had 17 columns, for example, and 17 columns, each of the column had a certain data type, and it had a certain cardinality in each of the column. If you don't apply the same techniques for your new incoming data, then it will not have the same number of columns, it will not have the same data types, your model will not do the scoring, it is going to actually fail. So you will get to know immediately. So irrespective of, I mean, that's given. If you're doing some pre-processing on training data, the same pre-processing has to be done on test data as well, or test data, or even the new incoming data as well. Absolutely given. I'm sure you would have learned that from your course as well. I'm taking Gaurav Srivastava's question. What is your suggestion for me? I have 5.6. Basically, what area I should be focusing on? Gaurav, I did an industry session yesterday for AI ML course. Uh, okay, so Piyush is waving at me saying that's a different that's a different team that I've talked to. It's a separate topic, Gaurav. I'm not in a right position to answer that question in like 2 minutes. So I will, maybe I'll reach out to you later. I'm sorry, I'm not able to answer that question now. So basically, you're asking what area should you focus. Maybe for now, you just need to refresh your ML basics and how to do things, and after that we can talk about it. So now I'm going to talk about Gundappa. Will it create any loophole for hackers if I use Flask and Django, etc.? Is it safe to use Flask with production when we have important data in production? Yes, Gundappa, that's a wonderful question. So when you are productionizing a model, you are productionizing the model behind a firewall in a company. So the firewall already has basically some restrictions on how data is exposed outside and all. And you talked about AWS instance, hosting it on AWS instance and all, right? Those things also are bounded by certain security norms, right? So it's not easy to hack. It's a piece of software that you are internally exposing within your organization, right? So whatever penetration test that has to happen on the web application, this will also go through the same thing. Apart from that, Flask in itself is just a piece of Python software that is used to expose your model as an API or create GUI. That's about it, right? I hope I answered your question, Gundappa. We will take Yogesh's question. I assume we can call the request API through some REST clients, etc. instead of writing Python. Yes, you could. You could. It's a REST API. You can do whatever you want. It's like a normal API. If you want to download extra library for joblib as for a speaker, yes, you should do conda install joblib. Bandana Kumari, yes, you need to do conda install joblib if you don't have it already. In real time, Rachit Kulati asked me a question. In real time, what is the time period in which you retrain your model and put back on your production? Every 6 months, business will come back to you and ask you to test how model is performing. There is something called online learning, reinforcement learning. There is also something called as calibrating the old models. These are topics on its own. Very good question, but these are not production related. This is post production activity, right? After some time elapses, what will happen to the machine learning model, right? It's a session on its own. I'm really sorry I can't cover it in 2 minutes, Rachit. We will have a separate session for it. Thank you for acknowledging, Rachit. I'm glad it makes sense for you. Birendra Panwar asked me a question: Is there a library for pre-processing techniques? Yes, there are lots and lots of libraries. I'm sorry, I don't remember on top of my head. Yeah, but if I remember anything, I'll just post it to Piyush. He can share it with you guys. Yogesh asked me a question. Yeah, I think I answered that question already about API, how to call the API and stuff. Nagapavan has the last question. Dataset scaling can be done to individual trained datasets, or we can have a dataset scaling to whole dataset at a time. Good question. Yeah, you generally do it. So whatever scaling you have done to training data set, you will have to apply the same to test data set as well. You cannot do scaling only for test data set because it's just fewer items, right? When you do scaling, the scale is skewed, right? If the range in your training data is 1 to 100, there is no guarantee that you will have 1 to 100 as the range in test data set. So you will have to use the same scaling parameter here also. Life of a data science. Gaurav Agarwal has a comment. Yeah, life at the beach. He says life of a data scientist after AutoML. He had some palm trees. I'm hoping he can chill out. Yes, we chill out quite a bit. Gaurav. Uh, yeah, these are smarter ways of doing things, boss. As simple as that. Did I answer that question, Gaurav? Chill out. uh, no. See, Gundappa has a question. So we have to scale the data set before training and test split step. Yes, we have to do scaling as required while in development phase. But what I was talking about scaling for Naga Pawan's question was in production, when the new test data is coming in, when I say test data, it's unseen data, you use the same scale that you have used while developing the model in training. All right. All right. I don't have any questions. I feel like a maverick. I've answered almost all the questions. And I also found my new profession as a radio jockey. All right, Yogesh has another question. That means in order to process the new data, we need to know what MO. Yes, that's what you will see. I showed you, Yogesh. Yogesh has a question. That means in order to pre-process the new data set, we need to know what AutoML brought out with the best model. Yes, that is what you need to know. And I showed you an output folder, right? If you go into that folder, you will see the exact Python code that it has written to actually pre-process your data. Right? You can actually read the code. It's in human readable Python format. And from that you can do that. In production, how can we scale the test data is the question from Bandana Kumari. That's part of the productionization script. When you load your pickle file, before that, you also accept the data from somewhere, right? Maybe direct through a direct connection through database and all. Once you get it, you write the script there. You copy paste whatever pre-processing steps you have done from the training file to this place, to the, you know, um, to the test script or productionization script. Rachit Kuleti asked me, sorry, joined the session a bit late. Can you share your LinkedIn contact so we can keep in touch? Of course. I just displayed my LinkedIn profile. You can connect with me here. All right. If we do scaling on test data, I mean, Nagapavan has a question. If we do scaling and test data during production, do we scale the production data and pass scaled production data to model to predict? Correct my understanding? Yes, that's right. You will have to scale your production data as well. The reason being, uh, the reason you scale it is you don't want one feature to be the most dominant feature in your data, right? That's the reason you were doing scaling. So you will have to perform the same step on production data as well. Your understanding is right, Nagapavan. All right, so I'm not getting, can you share notebooks as well? Yes, Piyush is going to share all of them to you post the session. I've already handed it over to the Great Learning team. Okay, no more questions. We call it a day. All right. Thank you, folks. It's been wonderful talking to you. I really loved it and learned so much, and it gave me an opportunity to recap all the concepts. And I hope all of you got benefited out of the 3-hour talk. Sorry if I've bored you with a lot of theory in the initial the first 1.5 hours, but that was required given that we need to consolidate all that we have learned in the last 6 months. All right. Thank you so much. Looking forward to joining you once again in the next session. Cheers. Bye-bye.